वहाँ पे भी काफ़ी खूबसूरत जगह है जो आपको लगेगा कि आप किसी हिल स्टेशन पे आए हैं, समुद्र के किनारे आए हैं, आप स्वच्छ हवा, उस वातावरण को एंजॉय कर सकते हैं। जो अदर ऑर्गेनाइजेशन से आए हैं, आप भी ज़रूर एक बार दामोदर की घाटी में सैर को निकलिए। एक छोटी सी झलक दामोदर की घाटी में क्या क्या है, इसके बाद हम लोग ऑफिशियली इस प्रोग्राम को प्रारंभ करेंगे। समीर,
बोर हो रहे हैं, घूमने चलेगा?
कहाँ?
वो दामोदर की घाटी में।
अरे वहाँ क्या मिलेगा?
आओ दिखाते हैं।
पंचायत में कुंड मिलेगा, हारों का झुंड मिलेगा, पंचकोट के गढ़ दिखेंगे, कोटे और पर दिखेंगे, मंदिर मिलेगा, झील मिलेगी, छोटे हाथी की फील मिलेगी, और मिलेगा पंचत डैम दामोदर की घाटी में। दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में। जय चंडी में शक्ति मिलेगी, तेल कुपी में भक्ति मिलेगी, दशहरे की साड़ी भी है, डोकरा शिल्पकारी भी है, कल्याणेश्वरी दहील मैथन की खूबसूरत झील, टापू मिलेंगे, जंगल मिलेंगे, और मिलेगा मैथन डैम दामोदर की घाटी में। दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में। रजरप्पा में नदी किनारे देखो शक्ति पीठ पुकारे, पार्श्वनाथ शांत करेगा, कोनार खुशियां भर देगा, हजारीबाग में झील दिखेगी, फिर केनेरी हिल दिखेगी, बड़े बड़े जंगल भी है, नरसिंह का टेम्पल भी है, बैट आइलैंड, झुमरी तिलिया, और मिलेगा डीवीसी डैम दामोदर की घाटी में।
7 जुलाई 1948 जब भारत में संविधान नहीं था तो पार्लियामेंट के स्पेशल एक्ट से दामोदर घाटी निगम का गठन होता है। इसके बाद पिछले लगभग 80 सालों से दामोदर घाटी निगम देश की उन्नति में अपना योगदान देता आ रहा है। 2012 एक ऐसा प्रोजेक्ट जो 1000 मेगावाट की क्षमता के साथ दामोदर घाटी निगम में अपनी क्षमता को ऐड करवाता है और पिछले 14 सालों से लगातार उत्कृष्ट प्रदर्शन करते हुए देश के सर्वोत्तम थर्मल पावर प्रोजेक्ट्स में अपना नाम सुनहरे अक्षरों में अंकित कराता है। और आज सबको इस सभागार में जितने भी लोग मौजूद हैं उन सबको मैं बताना चाहूँगा कि आज दुर्गापुर स्टील थर्मल पावर स्टेशन का वर्षगांठ है, रेजिंग डे है। एक बार जोरदार तालियां उन सारे लोगों के लिए जो डीएसटीपीएस में लगातार अपना समर्पण देते आ रहे हैं। इसके साथ ही मैं राजीव रंजन सिन्हा और मेरे साथ महली समंता आप सबका स्वागत करते हैं दूसरे दिन O&M कॉन्फ्रेंस में।
A very good morning and warm welcome to all our esteemed guests, distinguished dignitaries, participants and delegates who have joined us from all across the nation to dignify and glorify and enrich the Day 2 of O&M Conference Powering Progress 2026, which is very aptly themed on integrating green initiatives with thermal excellence. Because we all know that green, blue, and coal, that is black, should go hand in hand. Isn't it so, ladies and gentlemen? Day 1 has been a plethora of networking, conversations, and solutions to pertinent O&M issues that will definitely go beyond this conference room to our BTG floors. Day 2 is expected to be even bigger and better with all your participation and enrichment. So ladies and gentlemen, without further ado and with all your permission, let us begin today's session with a panel discussion on the topic, Leadership Talk on Integrating Green Initiatives and Thermal Excellence. And for this panel discussion, may I invite upon the dais our esteemed panelists, Executive Director Commercial, Damodar Valley Corporation, Mr. Sanjeev Srivastav. Please put up a round of applause as we invite our esteemed panelists for today's session. May I now invite Executive Director of Fuel, Damodar Valley Corporation, Sri S.K. Pandey onto the dais, please. Please put up a bigger round of applause. May I now invite upon the dais Executive Director, System, Damodar Valley Corporation, Sri Dinesh Singh onto the dais. I now take the pleasure to invite upon the dais Executive Director, Project and Planning, Power Development Corporation Limited, Sri Sameer Chandra Ray onto the dais, please. Welcome, sir. With equal honor and pleasure, I would like to invite upon the dais General Manager, Bharat Heavy Electricals Limited, Sri Sagar Neel Ghosh onto the dais, please. Welcome to DVC, sir. With equal pleasure, may I now invite upon the dais Domain Expert and Senior Advisor Distribution, former MD CESC, Sri Debashish Banerjee onto the dais, please. I would like to take the pleasure to welcome you, sir. Now, may I invite upon the dais Senior GM and Head SLDC Damodar Valley Corporation, Mr. Sanjay Sharma onto the dais. We have a bevy of dignitaries on the dais. To take you through this panel discussion, I would like to invite the moderator for this session, Sri Shankarnath Mukhopadhyay, Domain Expert, T&D, Damodar Valley Corporation. Over to the moderator and chairman of this panel discussion, Mr. Mukhopadhyay.
Good morning to all. Very good morning to the eminent panelists who are the leaders of either of DVC or other organizations and taking the arduous task of making the landscape of India through higher generation and meeting very steep generation targets. Now, the target meeting is one aspect. At the same time, maintaining the global sustainability is another very, very big issue. Now we are, making a very tightrope walk. We know that the globe is on the threshold of a major problem of global warming, and for which particularly the generation sector is really, thinking to the extent possible how best it can be controlled. Now, if we see that the General Sustainability Goal, which was conceived in the year 2012 with 17 sustainability goals, of which the goal number 7 is clean energy and clean and affordable energy. There are other also 17 goals. It starts with zero poverty, zero hunger, and so many. But we are here concerned with the ultimate goal of, our generation sector. And if we take the case of our country, since independence, when the generation was only 1362 megawatt, now we have crossed about 534 gigawatt. So the rise is very fast, very steep, but this is not enough. We need to go further. The implementation of renewable energy, which is a call of the day, and we are really, our country is really maintaining the growth target. Presently, we are about 53%, 53.4% to be more precise, on the renewable regarding the installed capacity, and thermal is around 46.6%. But that is not enough. Our thermal contribution is around 74 to 75%, and rest is coming from renewable, that is green energy. So maintaining the green energy, which is also a challenge, everybody realizes that. And at the same time, our projection says that we need to grow much, much faster, because our per capita energy consumption is only 1460, whereby 2030 we have a target to be close to 2000. Considering the Indian growth pattern, our growth pattern is to the extent 6.5% GDP, and today we are economically at the sixth position. We were in the fourth, but we slipped to sixth because of various reasons. But by 2030, if our economic grows at the present rate, we will be the third. So the huge demands are coming. Now, to the leadership, I do have some queries and try to know that what is their view. First, I ask our eminent leader from WPDCL, who is looking after both the, project and planning, Sri Shomir Chandra Roy, sir. What is, what you perceive for the next 5 to 10 days in the power sector, the challenges, mainly on the thermal power sector? What are the challenges you are foreseeing, sir?
Is it working? Good morning to all of you, to all, my regards to all the dignitaries who are on the dais, who are in the front seat and in the whole complex. Now, the very big challenge on which I have been given the opportunity to start, in that we from PDCL as well as DVC, maybe CSC also, what the first challenge we are facing today is the drawdown issue. 3 years back, we thought always that whatever we will be generating, it would be going through the grid as long as the load requirement is there. But today, we are only able to produce 70% during the daytime, though our capability is there. For all the power sector companies across the country, more in the eastern region. You know that what Sir has right now told, that more than 150 gigawatt of solar and other renewable generations has already been implemented. And the generation level is to the level of 55,000 megawatt per day, approximately. Now, comparing to that, we from West Bengal Power Development Corporation, our total installation is around 4,900 megawatt. But we are able to produce today, at the peak of summer, how much? 3,100. We are able to produce, but we are not getting, because the solar power is coming at 3 rupees. The wheeling charges, which was a boon for the country, but today it's not becoming a boon for eastern region power producing companies. For DVC, for West Bengal Power Development Corporation, must be for CSC also. When the power is coming at 3 rupees, 3.2 rupees, Our generation, which is maybe at 5.5, it's no worth doing that. So the decision is coming that, okay, you draw it down, take the solar, and you do the generation once again in the evening. So the first challenge which is coming up, that every day you bring it down and every day you walk up the stair in the evening, which was not an affair. This is a very big challenge technically to maintain a power plant in this condition. It cannot be operated like this on a very long term and become very much commercially viable. The commercial viability gets a hit because when the calculations are done for a 25 years generation and the profitability and the rate, it is not calculated on this basis. It is done on a uniformity basis. And that uniformity gets violated when intermittently the market conditions change. When this market condition is affecting us at the 500 megawatt, 660 megawatt, and for other companies maybe at 800 megawatt, DVC is installing around 3000 megawatt new units of 800 megawatt size. For them to run a 660 megawatt, we are seeing our threshold is around 350. For 800 megawatt, it must be at 430, 440 level. Now, either you run it, and if you have to run it, this is the minimum technical level. We have in our dais Mr. Ghosh, who is from BHL. He will also explain in detail the technical difficulty in running such system and keeping it, leave aside commercial, the technically very viable. So what's the way out? The way out, which is coming out because every year around 30,000 megawatt of solar is getting added to the country. The only way out coming out is the base, which we all have to look very seriously how quickly and how fast at the individual plant level we can introduce the battery energy storage system, because whatever we generate, there is a optimization level. The optimization level of a thermal unit may be at 75, maybe at 80%. But 40% of a minimum technical threshold is not a very viable solution. So at least 75% or 80% level we generate, and then we store the energy in the battery storage system. And in the evening, obviously in the evening there is no lack of demand, though we don't see a lot of power cuts in the country in the eastern region nowadays. So it's a big credit to NTPC, DVC, PDCL, all of us, that we are able to give you power 24/7. And I don't think much of these interruptions or disruptions you have seen for last 3 to 4 years in this part. But to maintain that at night, we need to have a very quick and fast battery energy storage system. You know that in the other parts of the countries, there is a Surya Ghar Yojana, which gives us support for the power to be installed on the rooftop. But at the industry level, I think we all have to now work together to get kind of government support in getting the battery energy storage system implemented for the power utilities to get us commercially viable on a long run. That's the first thing. And on a very longer term, if I am to say, maybe I will come back in the second session, that is hydrogen. I will not talk it now. Let the other members speak. We'll come back. Thank you very much.
You have really touched the genuine problem in the grid level, where there is whatever car we say, if it is a dark car or canyon, whatever we say, that it is happening, and MTL level maintenance is becoming an issue. There are other issues also I will try to touch upon, and particularly the BSS is a very subject which is very close to my heart. But commercially, how it can be implemented, the policy regulations, what can be made for this is still, in a darkness. I don't know how these things is happening. So I now, at the same time, there is one regulatory expert who is looking after the commercial sides of DVC. I'll put this question on him along with the additional, there is one additional query I do have in my mind, that whether the existing regulations are helping integration of green power and maintaining high degree of efficiency in thermal operations. Because maintaining high degree of high efficiency in thermal operations is one aspect, and maintaining the availability of green power is on the other side. If it goes on the north, other goes on the south, if we take it commercially. So how this challenge can be accepted?
Good morning. I am answering first question. This base. Recently, CRC has come up with the second amendment in March. It's a really game changer for power industry because first time BESS is introduced as a transmission element. So the biggest problem what India is facing right now, construction of transmission lines, and there are substations in Rajasthan having capacity of 9 gigawatt. During daytime, 9 gigawatt power is flowing, and night there is no power, almost zero. So transmission, building a transmission network, building a plant outside outside of the load area, and then bringing it through transmission line and distribution and feeding to the consumer. But in this transmission, by installing battery storage near to load, we can avoid construction of transmission lines. So this is a very big boon for consumer as well as for DISCOM also, because by having battery storage at substation, we can provide the quality power to consumers, and our transmission lines and distribution lines are not loaded. And when loading is reduced, the transmission loss will be reduced, and ultimately consumer will be benefited. So this, and DVC is also thinking to install 2 gigawatt of battery storage at different substations. We have already made a study through one consultant, and around 220 kV level, 132 kV and 33 kV level, we are going to install the BESS. So this is already policy is there. It will all stakeholders will be benefited by this policy. Second thing, this thermal, what Raisa is told that really it's difficult time for generation power plant generators. But as DVC is an integrated utility, and I am looking after commercial part of generation, transmission, and distribution. All three parts I am looking. But the best part of this tariff determination is once your plant is available, then you are recovering the fixed cost. And by going up to 55%, if we reduce the load, there is a trouble for generator, I agree. But policy is already there. If for part load compensation policy is already there in CRC, we can claim that whatever the loss is, because the losses by having this flexibility operation is 5 to 7%, but the cost of storage, whether it is PSP or BESS, it is much more higher than these losses. It is 20 to 30%. So if we are having a choice, we should always prefer flexibility, and new thermal plants which are coming with supercritical, ultra-critical, they are having efficiency around 45%, mean increase of 10 to 12% increase of efficiency. Then, because green initiative is not installing RE power or solar power or wind power. Green initiative means reduction of emissions. If suppose right now I am producing 100 SPM, if I can reduce it by 20 or 30, it's a green initiative. So the new plants, new units are coming with greater efficiency, and thermal plants are not enemy of renewable energy. It's enabler of renewable energy, because earlier it was renewable energy, but now it's dispatchable energy. Right now we are having RE power, but we have to convert this RE power to dispatchable RE power, so that this by having flexibility, evening time the thermal generator will provide the base load, and daytime they will enable RE power to go to the consumer, because for industrial growth, reduction of tariff of our industrial friends is our prime importance, because if we have to compete with Europe and at international level, then our power cost should be on lower side. Because the way this coal prices are going up, this thermal power will be costly after 10 years. But once, if we install for battery storage or RE power, we can provide quality power as well as cheaper power to our consumers. So I think I have answered your query.
Thank you. Thank you for identifying the term of dispatchable power. Really, it's so. And so again, I go back to my right side and ask Mr. Shagarnil Ghosh. You know that the same challenge of, flex generation with the modern plants, mainly the thermal shock it has to bear, the huge fluctuations it need to be maintained to maintain the system. So what are the design modifications you are doing to make it compatible for the present scenario? What is in your mind?
Good morning, sir. Good morning, everybody. I'm audible? Your question is as OEM of power equipment.
Yes.
What initiatives we have taken?
And you know that the present situation demands huge fluctuations, maintaining efficiency, and at the same time, more stress on, less pollution with higher efficiency of the machines. So, considering the huge fluctuations of load on a daily basis, do you think that any modification is required to maintain your machines or boiler system so that it can serve the purpose without losing much of its age? The effective age is not getting hampered. So, what things you need to make change?
There are two aspects of this question. First of all, as BHEL, whenever supercritical technology we have developed, the first we started with NTPC bar in 2012-13. And subsequently, we are just now executed on Sagardigi project of WBPTCL. The heat rate we have reduced from that 660 megawatt supercritical to now Sagardigi is around 100 kcal per kWh. So we have changed the design of the supercritical units. Particularly, we raised the pressure and temperature much higher. It was started with 254 kg and it is now 275 kg at turbine inlet. And advanced ultra supercritical, it is closely near to it. So it is around 300 kg pressure and 700 temperature. So this is one aspect if you take it as a base load station. Now, whatever the eminent speakers have been telling, the problem is in ramping up, ramping down of station load, and C is asking for 40% to 100% in different ramps. This is a problem. This is a problem particularly if you go at 40% to 42% in supercritical units. I'm not telling about the subcritical. Supercritical units, the Benson point lies there. There is a state changeover from wet mode to dry mode to once-through mode. That state changeover is very unstable. Every time it gets less than 40% and more than 40%. So number of equipment gets off and it is carrying a great risk of freezing of the unit also. Power?
Yes,
Okay,
yes.
okay.
It's audible.
Obviously, as OEM will tell that 40% is 43%, but practically it creates problem. That is one thing. Now, from 55% to 100%, you are reducing only the pressure. The temperature remains constant. Because these units, the supercritical units, is a sliding pressure supercritical. So from 55, lower load to higher load, the pressure gets increased in a linear manner. But the temperature remains constant. So there is not much shock with the temperature. Yes, pressure will be higher and lower. So that amount of risk, I don't think that is a huge amount of risk, because if you can maintain the temperature gets automatically maintained. There is no issue in it. And the main difference is with subcritical to supercritical. The supercritical units are designed to run with atom pressure in surface. It gives the maximum efficiency with atom pressure, unlike the subcritical units. So temperature is getting controlled in a nice way. So that is only pressure, but temperature-wise, as you were telling, the stress on the equipment, I don't think that will be very large issue.
So, what I understand, okay, Shakunil, so what I understand that around 50% to the full load, it doesn't have much of problem. Only thing, if we go beyond, below 40%, there is some...
Actually, the problem comes near to 40%. So people are working on it, but that was future design. Because
Right,
DVC
right.
is coming up with so much supercritical units at 800 megawatt units. So they will have to cope with it.
Now I will come to a different aspect. In fact, I'll ask Mr. Sharma so that. Sir, DVC is right now emerging as a big player. It was a big player, but it is becoming much bigger. Out of 7 gigawatt, it will go up to 14 gigawatt in the coming years. With addition of supercritical, ultra supercritical machines, BESS, solar, pump storage, and so many new things are on the anvil. So there are two aspects. One is managing the entire operations, because you are right now looking after operations of different aspects. This is one way. And second thing is that for every new technology, there are men behind the machine. So the people quality needs also to be upgraded so that they can give proper output and reliable power. So what are those aspects in your mind? One is the operational aspects, and the other is how people, what type of knowledge you expect the people should have, so that you can expect a very, very efficient operations.
Okay, good morning all. First of all, the first question, what the grid is facing the challenges within this integrating. First of all, I want to say, day before yesterday, the frequency fall below 49.4 hertz. It was 49.39 hertz after a very long gap. And in that scenario, there are certain defense mechanisms which need to add, and it happened 0.55 hertz. It happened in a matter of only 19 seconds. This happened due to outage of 10 gigawatt solar in the western region. And there are certain defense mechanisms which a grid has to have, that is the under frequency shading and this AGC control and free governor mode of operation. These are available with the grid operator, and in that condition, it may be surprised DVC supported 150 megawatt load of DVC set automatically, and out of our commitment of 170 megawatt. This was, and second, from the AGC point of view, in that situation, DVC gave 75 megawatt, supported the grid at that point, and all the generators of the ISGS are supporting the free governor mode operation and supporting the AGC. This is playing a big role in stabilizing the grid. And the second aspect is use of, presently we are not having much sort of a battery storage system. So this battery storage system will not only balance the load, but it have a very good ramp up and ramp down limit also. This will be used for the grid security point of view. Right now in India, during the solar hours, when the solar hour is coming there is a requirement of 1.6 gigawatt power, ramp up per minute. But right now we are having only 0.8 gigawatt from the trash services which the NLDC is operating. So this factor, that is very difficult to maintain the frequency. And this battery will also support the grid voltage, which is very much required for the sustainability point of view. And in European market, this ramp up, ramp down market is also there, which I think in future in India, it is also likely to come, the ramp up, ramp down market. And second question, which was the upgrading of the knowledge of the person posted here. So there are the certification course of the grid operation conducted by NPTI, and this year I say around 80% of the person posted here are already been certified in DVC. And there is the second aspect, the person posted in the load dispatch center should also have a knowledge of the cyber security aspects. And there also the certification need to be given to the employees posted in the grid operation.
Thank you, sir. But my question is that only one aspect of training will not do. The training should be holistic, because all corners, if we want to be a more reliable, more proficient power generator and supplier, all corners should work at the same frequency. Otherwise, the synchronism will be lost.
The different type of training are important.
So for every aspect, the quality of manpower also needs to be upgraded with new qualifications, so that the high rising demand and extra power generation will also get extra efficiency. Our people are excellent at this level, but again it need to be further ramped up to match with the future expectations, with the modern technologies.
Okay. That is okay.
And I'll ask my next questions to Mr. Singh, the ED systems. Dineshji, again the huge rise of DVC's power sector, what we have already discussed. Now you are looking after transmission. So do you feel that whatever transmission network we have, these are sufficient, or we need to develop further more transmission networks to evacuate this power? At the same time, what modern technology you are envisaging for maintaining a much reliable transmission system and further transmission equipments, whatever we have, whatever in the maintenance practice, anything new you are thinking, sir?
Good morning, everyone. Since yesterday, actually, we are listening to all eminent speakers, and the message is very clear. Renewable is eminent, But at the same time, thermal is also going to stay, and as per the resource adequacy plan made by CEA and government, by 2035-36, 1121 gigawatt altogether generation capacity need to be there. And if this is a national commitment, DVC being a responsible power sector government company, DVC has the similar commitments, and DVC is also proceeding on the same path. Approximately 15 gigawatt plus generation is coming up. And at the same time, all the challenges which are going to be there on national grid will be there on DVC grid also. Sir, as the case you must have heard, it is there in the news also, almost 47 gigawatt of renewables is stranded nationwide because of want of your readiness of transmission infrastructure. So, yes, probably on the generation part, the policies, the capabilities, probably we are a bit comfortable, but transmission part, we are lagging a bit nationally. There are policy interventions required on many aspects. ROW is one of that. Statutory clearances are the other, forest clearances as well as your other government clearances. So these things are delaying the transmission project. And at the same time, your national capabilities on manufacturing is also, increasing the transmission project timelines. Especially, I would like to quote the availability of transformers. If we talk about large capacity transformers, it's not available before 30 months if you are talking about 500 MVA or so. But having said that, specific to DVC, actually we have also prepared our plan up to 2034-35. Your intrastate resource adequacy plan of DVC, which has already been approved by CEA. And we have also used capacity augmentation in the system. We are working on 3-4 major aspects I would like to quote. One is your capacity augmentation to match both generation evacuation requirement from upcoming your renewable battery storage as well as thermal power plants coming in DVC. And second part is making the grid, upgrading the grid, making it ready to take care of all the technical challenges because of renewable integration in the grid. You must be aware that major issues, technical issues which the grid is facing and is facing in, the severity will increase in the future. One is variability. Just now Sarmaji quoted the issue because of your sudden your outage of renewable from the grid. And in DVC, the UFR system, under frequency, your isolation of loads acted upon, and we successfully could help the grid to stabilize. So this is one part, but the problem is more severe, which is going to come in future when we will have 70% renewable in the grid and approximately 30% your thermal capacity, which is as per your the target taken by the government. Right now it is 53, maybe 47, 48, something like that. It is going to increase to 70% non-fossil fuel and 30% fossil fuel-based capacity in future. So in that way, actually, the major issues will be your issues of variability, voltage issues, your inertia, the grid inertia issue. And for that, we need to put some systems in the grid, like some systems are already there at national level, STATCOMs, SVCs, and we are also talking, because we are going to renewable, so we are also talking about grid forming inverters in place of the grid following inverters, which is right now being put. So those are the newer technologies we need to evaluate, we need to put at the right places wherever required. And your technologies like synchronous condensers, which also need to be incorporated, because these your equipments and technologies give synthetic inertia to the grid. And an inertia is a major issue, must be knowing the issue faced by European grid. last year, and a major outage was there. So these are the challenges. We are working, we are studying the system, we are assessing the load requirement going to come, and the generation going to come, and then we are acting accordingly, sir. Thank you.
Thank you, Mr. Singh. You have very rightly pointed out a crucial issue of inertia. More solar is being added in the system, the total moment of inertia of the entire power sector is coming down. So what is planned that the old machines, rotating machines can be used as synchronous condenser to maintain the grid inertia. At the same time, the power factor also gets impacted, it will be improved. So this is a very good idea. Right. Now again, I come back to the thermal and the efficiency parameter. My question goes to Mr. Pandey, who is looking after the fuel aspect of DVC. That, well, in India, whatever fuel is supposed to get, normally we get some slippage. But still our expectation that we should be the, best producer of electricity and, with minimum possible emission. So this is really a challenge. So my query to Pandey Sahab is that how you are looking into it and what are the possible ways you try to combat such challenges.
Thank you. Good morning, everybody. I will start from the aspect of DVC. DVC having average coal consumption of 28 million metric ton per year, average. And for the 28 million metric ton coal consumption, we are having 20.247 million metric ton FSA from CIL, 11.551 million metric ton from BCCL, 6.061 from CCL, 2.488 from ECL, and 0.147 from MCL. See, quality of coal of ECL, MCL, and BCCL or CCL, all are very, very different. One more thing I want to add here, there's 6 million metric ton of our Tuvaid. So Tuvaid coal and MCL coal are at the par. Since yesterday, we are hearing, or not only since yesterday, since long time we are hearing the proper good quality of coal. But I differ from here. We require appropriate quality of coal here, proper quality of coal. Few days back, at MTPS, unit was not able to reduce the load due to good quality of coal also at the solar hour. So we required appropriate quality of coal here, and appropriate quality of coal requires in the high VM at the solar hours and high GCV at non-solar hours. So going through this cycle, one of the most important point here is the blending of coal. Proper blending of coal with the use of technology is most important, and we have to implement it at everywhere. So that we can reduce the load at the this solar hour up to 55 or 40, whatever it may be, and we can achieve it at the non-solar hour. So we can't lose any money from this account. One most important point here, the blending is the one solution, only one solution here, with the reappropriation of the GCV, so that the feeding and data capturing based on the available data, we can operate the machine, the controller at the panel, and the controller in the CHP should coordinate in such a way that the load should not go above in the solar hour and below in the non-solar hour. One point I want to say here, that as far as clean energy concept is concerned, most important point here is what we have discussed here, the dispatchable power should be there. Dispatchable power means cost-effective power should be there. So if we see the emission percentage and based on the only control the emission, we will not able to give the proper the proper energy rate to the market, to the consumer also. So we have to balance from both sides. Okay. As far as clean energy is concerned, we are going for the around 55 million metric ton of this power was curtailed. So in this aspects, solar thermal will be the most important and appropriate system to integrate with the grid also. So as far as DVC is concerned, DVC is committed, and we have already started the blending of coal with the less ash FGD and implementation of FGD and DNOx system, less ash with the proper mixing of the good quality with the grade 14 or grade 13 coal, and we can achieve the emission level also. Thank you very much.
Right, Pandit Sahab, so that appropriate quality of coal should be fed for the boiler to get the right response. Right, sir? Now, if we follow the entire power sector value chain, and now I'll go the last sector, distribution, where Mr. Devashish Banerjee is here. He is the ex-MD of CSC and an expert in distribution. Sir, my question to you is that, so far I know that it is perhaps the most challenging sector in the entire power value chain, because it is connected to millions of consumers and collection of bills and addressing their problems, giving them connection, and all these commercial aspects related to it. So the technology has come right now, which can little bit ease out the activities. Sir, what is your idea? I mean, what is your vision on that? How distribution sector can be improved in future, which for making the task bit easier?
A very good morning to all the esteemed dignitaries on the dais and off the dais. Well, I would like to reshape the reply. The entire GTD, generation, transmission, distribution system forms a unique part of the power system. So whatever units we generate, that unit is transmitted and billed to the consumer. The revenue comes from the consumer. So I would say that it's not that only distribution is important, generation is important as well, because we need to understand that our plants which are operating, power plants which are operating, and with this green BESS which will be operating, when we are talking of fixed dispatch renewable energy, we have to ensure the uptime of the plants as well as the transmission distribution system, so that as a business we don't lose the revenue from the customers. So if you look at that, if you look at any business model and you look at any P&L account, you would see revenue is the top part and then comes the cost. So in the cost sector, it's very important that how do you reduce your O&M costs, because this is an O&M seminar. Now, how do you reduce your O&M costs? The O&M costs can be reduced in the generation, in the transmission and the distribution as well. But as they say, if you don't measure any parameter, you will not be able to analyze it, take action on it. So data, the most important part is data. So when we talk on so much of the entire GTD train, you see that humongous amount of data is being generated all over the power system. So how do we utilize this data in a form that we can ensure that the plants, right from the peak period of March to November, October, they run towards 100% uptime, right? At the same time, when we do this, we need to have two types of, philosophies which is embedded, and whatever I speak here is whatever I have done in my past and I'm trying to share with you. So this is the formation of a digital energy power system or digital energy grid. So what will happen is, suppose you have a trip history of your plant, whether it was a boiler tube leakage, whether it was it was electrical system, whether it was a transmission line system, whether it's a transformer failure. All these data which we have, rich data of the organization for last 6 years, 7 years, they're all maintained on an Excel sheet, generally, correct? And these are all manual. Now, when you try to take out the manual bias and make data-based decision making, you need to put all these data into a kind of a model, which in our earlier times we used to call a statistical model. So today, what is AI is nothing but is an artificial intelligence where the intelligence is taken from the people who have recorded these over so many years in various words into a machine. And the machine goes on learning, so that's machine learning. So once you apply an algorithm to what was the causes due to the trippings which has happened, whether it's in generation or transmission distribution side, you come to a correlation to understand which are those parameters which you should, which you should measure, we should keep control so that you don't face the same problem again and again. Now, this is the past, which is AI/ML. The future is when you put a real-time conditioning monitoring system or IoT-based sensors. That means, like we measure our blood pressure, our sugar, etc. So you measure the health of the asset. And let me tell you, asset of a general power company is the largest. So there is something in the books of finance which is known as gross fixed asset. Now this gross fixed asset decides the economic value of an organization. Very important. So if you have to keep these assets, going. I remember during my time when I was in Reliance, we had a residual life analysis of our plant in Dhanu, 500 megawatt. Even after 25 years when we were going for extension of the license, it was found out, and Bell did the study, that only 30% of the life has been expended. Can you imagine? That plant will run for many more years. The plant will run for 15 more years, 20 more years, and today we need that plant because thermal today has become, is the base load. The peaking load today, especially when we are facing the night time, is going to be the battery energy storage and the wind power, which is the green part. So the point here is, when you ensure that your O&M practices, whether it is in a plant or it's in transmission distribution, you maintain it, it will be nice. So for example, you want to ensure that the combustion is right, fuel mixture is right, your heat rate is better, your auxiliary consumption is low, etc., etc. These all can be fed through a sensor, and these data, when you combine with your past data of the last 7-8 years, you will come to an automatic model which will ensure that it is based on data and the machine, and this is not based on human decisions. So what happens? It becomes an automatic grid. The automatic grid is like a SCADA, the ERP, the GIS, the power plants, the distribution, transmission system, they all become in an autonomous grid. So I will tell you something, these things will help the organization ensure that while its uptime revenue is maintained, you earn more revenue, your O&M costs go down. That means you are doing just in time. We used to have something known as just in time. So whenever these data of the sensors say that your things are going to fail, you please do this. For example, let's say the tan delta of a transformer is going to be 1 or something, you have 2-3 months to do it. Something in the plant, it says you will have to do that, you have 60 days to do it. Otherwise, if the plant fails, or the distribution line fails, the cost of this replacing those parts is humongous, which is undesirable, and you can extend the life of the parts by doing a predictive maintenance. So you have to move from a regime of a reactive approach or a preventive maintenance to a predictive maintenance. So now these kind of things are also applicable into, for example, when there is a thermal plant which is going to be at, let's say, technical minimum 55% or more, in the night time during the ramp down or something, the BESS comes in as a buffer. Now, in the other time, the wind comes in. How do we measure and how do we ensure this grid becomes autonomous? Because humans can't do it. It is a very laborious process and they may miss. But when the system is monitored to an intelligent system, this automatically the mix of the thermal and the rural, including the markets. That means you can sell in the market when you have extra good power and you have good power during the peak time. So you get more revenue, your earning cost goes down, your profitability goes up. You can take that profitability and put it into a capex, get a better ROE, and in the whole process, you are going to develop a system which is optimized. See, these kind of systems are also used for load forecasting, like weather forecasting, the availability of the power in the system whenever you are having some DSM charges, if you want to pay, how do you control that? So I mean to say, it is so deep. We have just scratched the tip, not even the tip of the iceberg, but we need to ensure that each one of us, it's something known as an agentic AI. When people talk about agentic AI, it's nothing but an agent which is autonomous, which monitors the system and helps you take a decision while not, doing these mundane things that you will attend to a kind of a leakage somewhere or welding problem somewhere or something. The whole system gets managed intelligently and you have more time and the decision goes to the edge on the workforce. So there's a workforce automation as well, and you engage your time in more strategic making decisions to ensure that, yes, how do you ensure that your wear and tear of the plant at 55% PLF or your technical minimum is still good. So I mean to say, this is such a huge and a vast topic. I have made a lot of notes, but I'll not be able to complete this because this needs a real absorption of the ideas that we have to get away from manual or human-driven systems into an autonomous, unbiased decision database system, and which is predictive and proactive.
Thank you, sir. This is something what we imagine in a smart grid truly operating, but appreciate India has at least 40 crore of consumers in a 140 crore population, and with their very low economic level. So how far the financial support can be given to maintain such automation? That is also a question, sir. So.
You were saying that the cost of putting an AI/ML system?
I mean, it is basically AI/ML is the operator, but you have to, the system has to have such sensors, such automation devices. So putting the grid into automation, definitely it will make the system more efficient. But it is going to be real at a later date.
So I'm trying to tell you.
Sir, let us stop here.
1 minute, it is self-sustaining. When you have lesser outages, when you increase the transmission capacity of the lines, you reduce your capex, your cost comes in, and it's only a fraction of a cost of the total returns which you get in terms of top line and bottom line. And your break-even would be nothing more than 3 to 4 years or 2 to 3 years. And you will make crores of money, and there's a detailed calculation for that.
Okay, sir. Perhaps this is right. In the first round, we have taken a long time. In the second round, we'll ask very short answers. So my question goes to ED Project and Planning, PDCL, sir. In fact, in the ensuing projects, all the companies, there are possibilities of cost and time overrun, and which really escalates the project cost and many other challenges. So what risk coverage one should take to arrest such possibilities, to overcome such challenges?
Yeah, your question is very valid. When we go for a project which spans over 6 to 8 years time, practically, it starts with 4 years or 5 years, but practically draws down to 6 to 8 years time frame. There, as you know, you are also from the central government, we are from the state government. We issue the contracts on a fixed price basis. So it does not have much of price variations. Okay, even if there is some minor structural still price variations, we provide that in the clause and provide the money for that in a calculative model. But luckily that we are having a very long-term partnership with BHL. Mr. Shaganil Ghosh is here, and he has been our partner for maybe 3 decades. He means BHL and PDCL. This has helped us because wherever we have put in the thermal units, they have been very supportive in maintaining the price in spite of the hits which they have taken. I will again thank them that we have not faced much of a price of the project going up. The solar projects which we have built have been for a shorter duration, hardly for 1.5 to 2 years. There also we have gone with the fixed price and we have not faced much of a price impact due to delays in the project. And the biggest advantage which PDCL has, we build the plants within our premises, means it is within our fixed boundaries. Luckily or unluckily, we did not have any new project in a new greenfield plant. So we had not faced much of a price impact due to delays in the project. So I cannot often comment on that which industry is facing. I think I'm cut it out here.
Thank you, sir. Thank you very much.
Thank you very much.
Now my small question to Srivastav sir, if we talk about efficiency on electricity, 1 unit generated in the thermal sector ultimately becomes half at the consumer end because of various energy transformation, and finally the very poor efficiency at the consumer side. Normally the consumer side, the efficiency comes to the range of say even 0.6, 0.5. So 1 unit generated, basically half unit finally reached. Now to improve efficiency, the consumer training is required so that they can develop a better efficiency, but it is contradictory to the business of the utility. So how do you look at it?
What's happening, these in all industrialists, they are working for profit. And whenever they are making the investment, they are always calculating that by investing so much rupees, how much I will gain. And there is a variation on the other side when state government and central government organization like WPDCL, DVC, NTPC, they are working. We are putting much stress on reliability and quality. So we are also maintaining the quality of power and or whatever, we try to procure all efficient equipments. But the consumers are going to the market and they are searching for cheaper and which can serve their purpose. In doing that, sometimes they are procuring the motors, transformers, having high losses. So what we are doing, we are meeting the consumers. My team, along with system group, they are going to consumer premises. They are evaluating their equipments. They are advising what to do, what type of equipments you can procure. And we are also planning to engage some external agency which can go and meet all the customers. First, we will evaluate that what is the load factor, who are the consumers having load factor and this power factor on poor side. Then we will tell those external agencies to meet them and advise them suitably so that they can correct this issue.
So you are suggesting that consumer awareness development also a task of our organization, so that ultimately the energy efficiency of the entire cycle improves. Right, sir? Now my question to Mr. Pandey, that do you have anything in mind to go for, greening in the fuel side? What is in your mind? How best the greening application can be done for better sustainability?
See, as far as this process is concerned, we are already in the forward direction to bring the better quality of coal so that the level of this 34% level of ash can be maintained. Whereas it is very difficult nowadays. The ash contents is around 42 to 47%. We are approaching even somewhere it is 50% also. So, as I have told earlier, at present, washery is not the option for us. We are not open for washery system, but we are in the process to have. We are already we are having 11.551 million metric ton coal from BCCL, which is BCCL is supplying the vast coal also. So we are trying to take the vast coal from BCCL so that the optimal level of 34% or 35% ash can be maintained. One point. Second most important point here is as far as this FGD and this DROC system is concerned, we have already implemented this, and in this way we will try to reduce this environmental impact of this SOx or NOx. One most important point, we are already in the thought of the carbon capturing system. So in the carbon capturing system, we have talked with, and we are under the process in the some contract with the NTPC Netra, so that we can start a pilot project in DVC as well. But it will take time. It will take 1 or 2 years more. Thank you very much.
Thank you, Mr. Singh. Any modern method of maintenance you are preparing to implement for more reliable action and lower carbon footprint for the substations you are going to install? Anything you have in mind?
Two parts of your question. One is reliable operation, and another one is your carbon footprint reduction.
Right.
Reliable operation, actually, this is a always evolving process. We keep improving, on the available technologies in maintenance, and certainly a better your SOPs and more close observations of our asset. So asset management is continuously, improving day by day.
Right.
And we are using technology also, like putting IoT sensors, etc., to give the early warning for any kind of upcoming failure, such that we can take at right time, we can take the right step. So that is there with DVC also. Second part is regarding your decreasing carbon footprint. Actually, in transmission, unlike distribution and generation, losses are less. So in that way, actually, we are a bit comfortable because the less losses means your less carbon footprint in the operations part of the system. But at the same time, as for responsible consumption of the material used in the transmission asset, the technologies are coming. You are in replacement of SF6 gases, your green or your non-harming kind of gases are made by different multinationals, and though it has very less penetration in the Indian market till date, but as a symbolic gesture, the utilities are going for that. And DVC, not yet we have started, but certainly in future we will also be going. Similarly, your some improvement over the your transformer oil also has come in terms of your biodegradable oil, and that is also there. So These technologies are coming, and DVC being a responsible, forward-looking organization, we are also exploring those.
Right, sir. We're changing the design with lesser footprint and using changing the transformer oil, making more reliable system, condition monitoring, new asset management. So these are you have been implemented in your system. Thank you, sir. Sarma sir, you have anything in mind to maintain further, green implementation in the DVC system? Anything you have in your vision?
In my opinion, for making the green initiative, what is happening, a regulation is coming, SCEED, Security Constraint Environmental and Economic Dispatch. That it is only looking after not only the economics point, the plant which will be less polluting and less variable cost we will be given the high dispatch. In that way, the grid operation will minimize the emission as well as cost to the consumer.
Okay. Thank you, sir. Mr. Ghosh, anything you have in mind for, as green initiative in your system, which can give, lesser carbon footprint? Anything you have in mind?
Actually, we have implemented many things during the course of time for lesser carbon. Maintaining the boiler efficiency, one of the most possible leakage point is air preheaters. So, if you reduce the air preheater leakages, your efficiency will automatically get higher. So, we have introduced some air leakage control system in air preheater that can be operated by seeing the difference between inlet and outlet oxygen content. And that gap setting can be done. That is one thing. Then also we have introduced nowadays all coal mills are having a dynamic classifier, unlike previous ones are fixed. So you can modulate the PF fineness depending on the coal quality, and naturally when you have a higher fineness, your unburned will be less. There are also other things we are taking, say, in LP heater drip system. Normally in today's all these machines, all LP heater drip goes to, cascaded drip goes to condenser. Recent, in last 2 to 3 years, we have introduced the LP heater drip is pumped to condensate extraction pump discharge through deaerator. So we are much amount of energy can be retrieved. That is not lost in the condenser. There are also other plethora of things, but just three.
These are the major things which can improve more efficiency, right? So, thank you, Mr. Ghosh. Now, my last question goes to sir. Sir, what is your idea about the distribution system so that it can be more sustainable with a bit of green initiative? We talk about greening the grid. From the distribution side, what is your suggestion, sir?
Yeah, so point is, as the other speaker was saying, distribution side, when you come to distribution, come near to the consumer, correct?
Yes, sir.
So what happens that you can co-participate with the consumers, where the consumers put up some kind of solar.
Exactly, sir. Solar rooftop or solar generation.
Put a solar rooftop or the solar ground mounted solar, whatever it is. And you also supply your energy, green energy to them, because we are putting up our solar plants and BESS, right? So, as per the time of the day, so that they have a better price, the tariff is better. So by that, what happens that when you co-opt with the consumers, you can work together. And something comes to my mind, I don't know if it's right or wrong, but there is a form known as P2P, peer-to-peer trading on a blockchain. It's like an Airbnb. When some consumer is generating some green power and he does not want to use it, he gives it to us, we buy it from them.
Right.
And similarly, when we generate and we give it to them, and we reduce a little more of fossil fuel power. So this way it comes up. Similarly, the battery energy storage system, which when you talk about, and at the same time, obviously, when your workforce is using some workforce automation, your electric vehicles, so as a part of the entire system, you can green the grid on the transmission and distribution side. That's all. Thank you.
Thank you, sir. Thank you very much. In fact, in the discussion, we started with the primary challenges of thermal generation, and subsequently the requirement of storage came, pump storage, battery storage, to manage the upsurge of load, or making the changes in the generation matching with the demand. Subsequently, we have discussed about the regulatory issues and the efficiency improvement, coal technology. We understand that coal mixing, or this is becoming a mandatory part to make the right quality of coal at the right boiler. We have discussed about the grid requirement and the SLDC's role and the efficiency part. So we have more or less covered the major sides of power sector, and finally we have decided how greening can be done. So thank you all the leaders of DVC, WBPTCL and BHEL for coming here, giving your erudite deliberations. So here I conclude the discussion. Thank you. Do you have any questions, sir? Yes, sir.
Can we have a mic, please?
Mic is not working. Can you take my mic? You take my mic.
Yeah, just I made some adding some points because when we go for subcritical to supercritical, it is rightly said that the thermal efficiency will be improved, and also the CO2 emissions will be less. But the challenge is that material wastage part. But now we are getting the coal which is not up to the mark, high as content. So if we can go for supercritical unit, so we have to do much more advanced materials. And for this, for 800 megawatt or 600 megawatt, now SS347H is coming up, Super 304 is coming up. So the welding, just my 35 years experience is that welding is a key challenge for these materials, for dissimilar metal weld. As well as we have to clean the boiler and regular soot blowing capacity. And one more things to add for this, adding good CO2 emissions by biomass co-firing. Biomass co-firing 5 to 10% with carbon neutral fuel. So that is basically agriculture waste. But when we are going for that carbon neutral fuel, if there is some sulfur or chlorine, so this will create some problem in high temperature corrosion. So material wastage will be there. Apart from this high ash coal, that ash is having higher silica content. It is alpha quartz. So this will much more eroding the specimen. So the boiler tube failure is one of the challenge for that all subcritical or supercritical boiler. So we have to be very good practices for this, how to minimize this boiler tube failure by proper maintaining as well as a good advanced metallurgy and metallurgical study and also ND inspection time to time.
Thank you very much, sir, for your insights. Thank you all the esteemed panelists on the dais and the moderator.
I will just respond to your call. Maybe I can tell after the session. DVC, PDCL are both tied up with BHL. You know that. Okay, so all the major supercritical projects presently is being executed by BHL, and BHL has worked continuously for last 3 decades as a premier technical institute in India in developing the technology for the supercritical boilers. Since PDCL has just commissioned one 660 megawatt supercritical project with BHL, and me and Mr. Shagarnil Ghosh was there for 6 months there. So we know the criticality, and I must say that BHL has clearly put its best foot forward. The boiler leakage, the proof comes when you have erected the boiler tubes and then you do the hydro test. I am telling you, more than 50,000 welding joints was done for the first boiler hydro test, and it came out through without any leakage. So you have to be cautious and conscious 365 into 24 hours when the construction goes on for 3 years. And that BHL and PDCL jointly achieved. The proof was the boiler hydro test, which when it was done, it came out without a single leak. Now we have to maintain it going forward. That's the challenge which we from PDCL, CSC, DVC are continuously, the power sector is a continuous process. 365 days, 24 hours, we are on the job and we will be doing it. You will get the result by getting the power at your home continuously. Thank you very much.
Thank you, sir. It has been an extremely engageful session with very deep insights from all over the power sector. Thank you, esteemed panelists on the dais. Thank you, moderator and chairman of the panel discussion. I request Chief General Manager, Corporate Operations Services, Mr. Sanjay Sinha, to kindly come upon the dais and felicitate our esteemed panelists and moderator of the session with tokens of appreciation on behalf of Damodar Valley Corporation. Can we once again have a round of applause for the esteemed panelists and the chairman of the session on the dais? This panel focused on extremely engaging discussions.
Ladies and gentlemen, let the applause go on. This is 100 years of experience combined right now on the stage. The dignitaries on the dais have thrown light
on power sector, the transmission, distribution, and generation sectors, ranging from solar, thermal, hydel. It has been an extremely engaging session, and I'm sure you've gained a lot of insights from this session, just like I personally did.
O&M Conference 2026 has created this unique opportunity to hear experienced panelists, the experts of the domains in power sector.
Thank you. With that, we wind up the first half of today's extremely engaging session.
And now, ladies and gentlemen, we will have a 10 minutes short break, high tea session. And I would request everyone to use this session as an opportunity to relax, to interact with your fellow experts and delegates. And also, I would request everyone to assemble on time in the same hall so that we could start the session again timely.
Before you disperse, I would request our IT team to kindly flash the feedback code on the screen. You can scan the QR code on the screen and put in your valuable feedbacks. So before you disperse, I would request our team to kindly flash the QR code on our screen. You can scan it and put in your valuable feedbacks.
And followed by the QR code will be DVC's song and different videos which you would like to see. I surely know you would surely enjoy those videos. These are scenic beauties of DVC Valley area. So sit and relax and watch the video.
यार बोर हो रहे हैं।
पूष की ठंडी शांत सुबह और लहरों की चंचल कौतूहल, भोर के जागे खग विहग संग, मंद पवन भी करती हलचल।
जब अंधेरे से लड़कर घर घर रोशनी आती है, जब अंधेरे से लड़कर घर घर रोशनी आती है, तब बिजली बिजली नहीं खुशियाँ बन जाती है। जब उफनती नदियों को बांध संभाला जाता है, तब वो बांध जीवन का भरोसा बन जाता है। जब खेतों में पानी पाके मिट्टी मुस्कुराती है, तब उगते अनाज से घर घर रोशनी आती है। तब बिजली बिजली नहीं खुशियाँ बन जाती है। जब उफनती नदियों को बांध संभाला जाता है, तब वो बांध जीवन का भरोसा बन जाता है। जब खेतों में पानी पाके मिट्टी मुस्कुराती है, तब उगते अनाज से चेहरों पे खुशी आती है। जब सूरज की किरणें बिजली बनकर आती है, तब नई नई कहानी गाँव में लिख जाती है। जब युवा पढ़ता है सपनों से आगे बढ़ता है, तब आज का भारत कल के किस्से गढ़ता है।
विकास की इस रफ्तार में डीवीसी देश के साथ कंधे से कंधा मिलाकर दौड़ रहा है।
पूष की ठंडी शांत सुबह और लहरों की चंचल कौतूहल, भोर के जागे खग विहग संग, मंद पवन भी करती हलचल। खड़े वृक्ष हरे भरे बहुत सारे, देखो मैथन डैम किनारे। मनमोह विहंगम दृश्य झील का, उस पर बैठा घोर कुहासा। मानो बादल चूम रहा हो सुप्त जलाशय के ललाट को, लेकर मांझी नाव चला रे। देखो मैथन डैम किनारे। दोपहर में मीठी धूप की कंबल हौले हौले देह तपाती, फिर ढलते सूरज की किरणें लहरों पे करतब दिखलाती। और सुनहरी सांझ ढली तो आए निशाले चांद सितारे। देखो मैथन डैम किनारे।
यार बोर हो रहे हैं, घूमने चलेगा? कहाँ? वो दामोदर की घाटी में। अरे वहाँ क्या मिलेगा? आओ दिखाते हैं।
पंचायत में कुंड मिलेगा, हारों का झुंड मिलेगा, पंचकोट के गढ़ दिखेंगे, कोटे और पर दिखेंगे, मंदिर मिलेगा, झील मिलेगी, छोटे हाथी की फील मिलेगी, और मिलेगा पंचत डैम दामोदर की घाटी में। दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में, जय चंडी में शक्ति मिलेगी, तेल कुपी में भक्ति मिलेगी, दशहर की साड़ी भी है, डोकरा शिलकारी भी है, कल्याणेश्वरी दहील मैथन की खूबसूरत झील, टापू मिलेंगे, जंगल मिलेंगे, और मिलेगा मैथन डैम दामोदर की घाटी में। दामोदर की घाटी में, दामोदर की घाटी में, है दामोदर की घाटी में, दामोदर की घाटी में। रजरप्पा में नदी किनारे देखो शक्ति पीठ पुकारे, पार्श्वनाथ शांत करेगा, कोनार खुशियां भर देगा, हजारीबाग में झील दिखेगी, फिर केनेरी हिल दिखेगी, बड़े बड़े जंगल भी है, नरसिंह का टेम्पल भी है, बैट आइलैंड झुमरी तिलिया, और मिलेगा डीवीसी डैम दामोदर की घाटी में।
শান্ত হলো ক্ষান্ত হলো মত্ত চরণপাত, অভয় বরে সুপ্রসন্ন উদ্যত আঘাত. This simple yet stunning couplet, written in the impression book of Mazumdar Nivas by novelist Tara Shankar Bandyopadhyay, enlivens an entire canvas. DVC was established soon after independence as an entity to control and manage the Damodar River. It was a unique project at that point of time, with multifarious responsibilities. The notoriety of the river Damodar was such that the people living in proximity were mortally fearful of its destructive powers. It was the flood of 1943 that left great destruction at its wake. The impact was such that the inhabitants expressed their sorrows through songs.
দামোদরে বাহানেলো ভাসলো ঘরখানা, হায় হায় ভাসলো ঘরখানা, হরি হে কৃপাময় পথ দেখাও না, হরি হে।
The devastating flood of 1943 was an important stimulus for the formation of DVC. In the same year, the government of Bengal appointed a 10-member inquiry committee titled Damodar Flood Enquiry Committee, under the chairmanship of Bahadur Uday Chand Mehtab, the Maharaja of Burdwan, and the noted physicist Dr. Meghnad Saha as members for suggesting remedial measures. Their magnificent work paved the way for Damodar Valley Corporation as a corporate body and the only solution to a river basin problem. On the lines of Tennessee Valley Authority, Damodar Valley Corporation came into being on 7 July 1948. In these 75 years of constant functioning, DVC has been successful in taming this wild river. The vision of DVC is to be an integrated, diversified and sustainable power major, ensuring socio-economic development of the people and creating value for the stakeholders. DVC's command area is spread over 24,235 square kilometers in Jharkhand and West Bengal. Our assets include 4 dams at Tilaiya, Konar, Maithan and Panchet. Tilaiya Dam on Barakar and Konar Dam on Konar had their inception in 1953 and 1955 respectively. The length of Tilaiya is 366 meters. On the other hand, the length of Maithan Dam on Barakar is 4,427 meters. And Panchet on Damodar is 6,777 meters. These had their inception in 1957 and 1959 respectively. These dams help the water resource management of the corporation. DVC has supplied water thrice every year from its surplus water for irrigation purposes. There are automated rain gauges in all the dams that provide a quantitative forecast of precipitation. Damodar Valley Corporation over the last 75 years has developed a robust transmission and huge distribution network and expanded it from 132 kV to 220 kV and from 220 kV to 400 kV to serve its consumers and export power to other regions. Today, DVC is supplying power not only in its command area, that is Jharkhand and West Bengal, but throughout the country, and has a presence in Kerala and Karnataka in the south and Madhya Pradesh in the center. In the north, DVC supplies power to the states of Delhi, Haryana and Punjab. DVC became the backbone of the country's steel industry in eastern region, electrification of the railways.
Hello. Ladies and gentlemen, we will begin with our technical paper presentation sessions. So I request all of you to kindly assemble inside the hall and take your seats. Ladies and gentlemen, we will now begin with our technical paper presentation sessions. So I request everyone outside to kindly assemble inside the hall and take your seats, please. I request everyone to kindly take your seats, please, as we soon begin with our sessions.
लास्ट सेशन में सारे ऑर्गेनाइजेशन, सारे लोगों ने ये बोला, दिस इज द टाइम टू सेव आवर एनवायरनमेंट. इट इज द टाइम दैट एवरी ऑर्गेनाइजेशन, एवरी कंपनी is focusing on carbon neutrality, that they are targeting for net zero. सारे कंपनी, सारे ऑर्गेनाइजेशन एक ही बात कह रहे हैं, दे लव नेचर. मैं पीछे ऑडियंस से पूछना चाहता हूँ, कितने लोगों ने ये सुना है दे लव नेचर? अपना हाथ उठाएंगे. कितने लोगों ने सुना है दे लव नेचर? कभी कभी आपने नेचर को रिस्पॉन्ड करते हुए देखा है कि नेचर कहे आई लव यू या आई लव यू टू? किसी ने देखा है? आज मैं दिखाता हूं आपको जब नेचर कहता है आई लव यू टू. यहाँ नेचर ने खुद कहा, आई लव डीवीसी। वी ऑल लव डीवीसी। एक जोरदार तालियां डीवीसी के लिए।
Thank you. I think that sets the tone for the next series of paper presentations, which will definitely be centered around the theme of integrating green initiatives with thermal excellence. So ladies and gentlemen, with renewed vigor, let us begin with our technical paper presentation sessions. And for this, I would like to invite upon the dais our esteemed session judges, respected Executive Director Operation, Damodar Valley Corporation, Sri P. Sir. I would like to check the pleasure to invite Sir on the dais, please. With equal pleasure, may I invite upon the dais our esteemed session chair, Sri Sanjeev Srivastav, Executive Director Commercial, Damodar Valley Corporation. Please put up a round of applause for the esteemed session judges of this session. Now, with the permission of the session judges, sir, with your permission, I would like to begin the technical paper presentation session, and the first paper in today's segment is on the topic, Early Modernization of Turbine Hydraulic System. And to present this paper, we have from Siemens Energy India Limited, Mr. Harpreet Singh. May I invite Mr. Harpreet Singh onto the dais, please. This is an announcement for all the paper presenters to kindly keep your presentations restricted to 10 minutes. We can always continue the conversations and the discussions in this conference throughout our networking breaks. Thank you. Over to you, Mr. Harpreet Singh.
So very good morning, Mr. Analyst, and very good morning, the audience. My name is Harpreet Singh. I am from Siemens Energy. I am from Controls and Digital Department of Siemens Energy. We are responsible for controls upgrade. We are responsible for electrical control upgrades. We are responsible for turbine hydraulic upgrades also. So today I have a paper for presentation on Hello. Am I audible? Yeah. So today I am going to present a paper on turbine hydraulic system modernization. We are talking about the KW turbines. So if we talk about the capacity of turbines, it's around 70% of the power is generated from the KW turbines in India. So we'll just start. So if we talk about KW turbines, normally manufactured by BHEL and by Siemens Germany. So BHEL is normally as a Siemens OED designs, so they are a BHEL sense of the KW turbines. If we talk about the KW turbines, the present hydraulic system consists of two parts mainly. One is the turbine hydraulic governing control system, mainly 210 megawatt and 500 megawatt. For 210 megawatt, it's 8 bar system, and for 500 megawatt, it is a 36 bar system. So in this, it is two parts. One is the hydraulic governing. We have a hydraulic governors, we have a starting device, we have a low limiters, then we have hydraulic protections like overspeed bolt, axial trip, and condenser vacuum. Then we have electro-hydraulic converters like turbine trip, SOVs, ATTs, SOVs, and motors. Then we have a second part in the same system. We have an LP bypass hydraulic governing system. We are talking about electro-hydraulic converters, bypass limiters, a mechanical hydraulic system, spray water switch. So this is a legacy system. It is a 40-year-old system, more or less. Approximately technology is 40 years old. So we have a solutions where we can upgrade the system to the latest technology. If we talk about why we need a modernization, so it's a mechanical wear and tear is there. because it's normally a mechanical, hydraulic components and protection system. So we have obsolescence of old designs. There are many complex systems, like we have many oil systems, auxiliary oil, startup oil, trip oil, secondary oil, all the stuffs. So we have and we also issue of oil quality controls, like after so many years, there's aging of mechanical equipments like that, and then we have a turbine stress availability and stuff, all the stuff, we have 2 out of channels there. So this is an old legacy system. So we have so we go, how it is, we go for modernization. If we talk about the present system, yeah, it's a typical diagram of 210 megawatt hydraulic system. This yellow portion is normally hydraulic governing system, hydraulic speed governor, then hydraulic amplifier trim device, the low limiter and starting device. This portion is normally proportional to the going for the hydraulic governing system. And this green system is normally for electro-hydraulic governing system, mainly consists of a electro-hydraulic governor followed by some trimming device. And this red portion is normally belong to the turbine protection system, where we have main turbine, trip SOVs, changeover valves, overspeed test device, ATD SOVs like that. Then you have blue system. It is normally a hydraulic protection, like overspeed board is there, thrust bearing trip is there, condenser vacuum trip is there. These are hydraulic protections. Then we have others called like MOP and extraction load shedding relays. And then we have a control swing check valves and extraction valves. And then we have HP stop valve, control valve, all the stuff is there. The second part is the LP bypass governing system. Hydraulic converter is there, limiter pressure control is there. Then we have a LP bypass hydraulic protections like spray water, condenser vacuum, and temper protections. Then we have a LP bypass stop valve and spray valves. So this is a typical schematic followed in all KW turbines supplied by Siemens or BHEL in India so far. Yeah. This is a typical rack we are talking about. I think you're all aware of these components marked in the drawing. So it is applicable for all 210 megawatt or either 500 megawatt units. Okay, sir? So how we want to upgrade now? So if we talk about this governing portion, I will dismantle all the marked portion. I will dismantle the hydraulic speed controller, electro-hydraulic converter, test motors, CV motors, and I will replace with the single wall turbine control. I will put a E2H converter, one hydraulic converter with the same oil pressure 8 bar system, no change in servo motors, no change in actuators. So I will put a E2H converter on each servo motors and control the governing control from the DC room itself. Now it shall be a purely electronic governing system. If we talk about replacing, means I will replace with, for each HP balls, the LSR load shedding relay functionality shall be in the digital technology. I can take the DCS model, and the functionality of the extraction SOVs, we can achieve the SOVs. So this blue portion is normally responsible for the electronic governing system. Means it will replace the hydraulic governing system as well as the old legacy hydraulic governing system, and it will go for a new electro-hydraulic governing system, which operates the same oil pressure, no change in servo motors, no change in actuators. We will use the same oil system, same piping, just a small modification in the rack itself and the wall itself. Then if we talk about the protection system, so I will dismantle all the components. I will dismantle the overspeed bolt with the, I will give a 2x3 overspeed protection. I will give a trip at my SOV to the trip block. So I will replace all hydraulic thrust and pressure trips with a 2 out of 3 electronic protection. So I will use the CR functionality with the new SOVs and pressure trip control test all the pressure switches which are above and over the oil system like cylinder dismantled. I will dismantle all the mark system and replace with the electronic components. So if we talk about in nutshell, so complete upgrade can be possible with this dismantling, yeah, and we will have a pure electronic governing system, and we can replace the old legacy system which are operating 40 years old. So it is pure electronic governing system right now. So if you talk about the rack, I will dismantle all the components as marked here and replace with the For turbine protection, replace with two trip block. And if we talk about the E2H converter, I will put a converter on each servo motors. So every electrohydraulic converter on HP IP control valves, we will have a much control, precise control of the burning part. And we have a 2 out of 3 turbine trip block. It's still certified and shall be done very easily. Yeah. So second part is the LP bypass. So this is the LP bypass rack, and it is you all aware of these components. I don't have to explain for that. So this is a typical diagram for LP bypass system. So I will dismantle all the blue mark portion. I will dismantle electrolytic bypass converter, bypass limiter, follow piston, and I will put a new E2H converter for each valves. I will implement the functionality of pressure limiter or regulator in the DCS itself. And I will do the soft logic in the control system. So this is for the LP bypass governing system. And same thing we will do for the protection system. I will dismantle the water spray switch, water protection, vacuum switch, and the temperature protection with the new. And we will provide a new solenoid valve for bypass stream. Yeah. So this is the one of the examples. Yeah, where we can upgrade the existing LP bypass with the new technology. So this is the one of the example. We did it already in NTPC Frakka Sumadri. We dismantled the LP bypass rock. Here we have retained the follow piston, one option, and we will put a new proportional valve, trip solenoid valve, and stop solenoid. It is already implemented in NTPC Frakka and Sumadri. And there is one more example, Ramagundam. It is for 500 megawatt. So we will do it modification on the wall itself. We put a proportional valve on the wall itself, 500 megawatt. So in this, all the mechanical components are the dismantles, and also the pre-control device mounted on the 500 megawatt dismantled and replaced with a new proportional valve. So this is the benefits, means there is one of the most benefit is the no modification in the existing control system. Oil piping, HP, IPCP motors, we will use the same actuators. Simple fail-safe design with faster, precise, increased metering dynamo system. Flexible due to improved and steam mass fluorination. Towards it, protection is there. So these are the few benefits. And in the end, we can say early modernization of turbine control system, less maintenance and durability, sir. Thank you, sir. If there any question, you can ask, sir.
One question from my side.
Yeah.
Actually, have you visited or any thermal power station of subcritical unit 210 or 500 megawatts or 250? Mijia or Kodarma or Chandrapura, have you visited?
No, sir.
Actually, though we have carried out the fine tunings of the HPLP bypass, but sometimes we are facing the problem.
Okay.
Basically, I would like to say you that we incorporate the system in our 210 and 250 megawatts religiously.
Okay.
So that after tripping up the turbine, the boiler should be saved.
Yeah.
Because the opening of the HPLP bypass, which is supposed to be taken place well within the stipulated period, and that is not happening in our powerhouse. So we are facing a lot of the problems. So I request you, if you have carried out or in any NTPC plant of the 210 megawatts, that will be great saving for us. Nearly 30 crores we shall save in a year.
Okay, sir.
So you please see.
Sure, sir.
Or have you done in any?
Yeah, we have done in NTPC
210.
Frakka. Yeah, NTPC done. We have done 3 plants.
210.
Yeah, Frakka.
Frakka. Good. I request you to visit our plant.
Yeah.
So that you can give us the suggestive measures, and if some modification is required, we shall do that.
In NTPC Ramagundam, it is implemented about 3 years back. Ramagundam 1 year back, and Sumadri we just finished in December now. So.
Is it operating the moment in the class A protection? If the turbine gets deep, then the boiler doesn't trip. Boiler remains unchanged.
Yes, sir. Yes, sir.
Untripped.
Yes, sir. We have done a normal capital overall, sir.
Yeah, that is the main question. Shutdown
normal capital overall, sir. Around a 15-day job, sir. Yeah, the normal capital overall, sir.
At the time of the capital overhauling, how many days you require?
Sir, normally the work is approximately 10 days, 12 days, but we have to link with the overhauling team because the oil charging will come around after 25 days, 35 days. When oil is charged and we have to flush it, the system, all the stuff. So we have to sync with the overhauling team, sir. Normally we do it in overhauling days only, sir.
So please give us please share us the papers which you have done or documents which you have carried out it NTPC powerhouses, that is a critical unit 210 or 250.
Okay, sir. Okay. Yeah.
Hello.
Sir? So we can discuss later, sir. We will share you, sir. Not a problem, sir. Not a problem.
Hello. Hello.
Yeah. Yeah. Sir, there is no change in response time, sir, because we are using the same oil servo motor, sir. We are not changing the servo motor, sir. We are changing all oil servo motors only. If I talk about Ramagondam, in Ramagondam we trip two trippings, sir. We save 2 trippings, approximately. Yeah. Yeah.
Hello. This is, you are talking about this KWU?
KWU turbine, sir.
This is throttle governing.
Sorry?
Throttle governing. This is not nozzle governing, this is throttle governing.
Yeah.
Okay. But our RTPS 600 megawatt unit having nozzle governing. So please, advised by ED OS, please visit RTPS.
Okay, sir.
We are facing lot of problem in governing system at RTPS. Lot of problem. Many times, months together we are facing the problem. So if there any possibility to, even Siemens is engaged at this time also with RTPS.
Yeah.
So if you have time, you visit RTPS and have you any suggestion, please give it.
I'm just telling you, sir, this solution is already implemented in, not in India so far, but in Germany 25 years back, sir.
Please visit. Please visit our this is Shanghai machine.
Sure.
Nozzle governing.
Okay.
Please visit there.
Sure, sir.
Okay.
Sure.
This is my request from you.
Sure, sir.
Okay. Thank you very much.
Anything else, sir? Thank you, sir.
Hello. They say the quality of a presentation is decided by the number of questions asked. And this was really a knowledge-packed presentation. However, I would request our esteemed audience to restrict their questions and interact with the presenters of the stage and talk about their queries there, because we have a limited time and we have to maintain the schedule. So now I would request our esteemed session judges to kindly felicitate our presenter. Sri Harpreet Singh. Big round of applause. Thank you very much, sir. अब टरबाइन हाइड्रोलिक्स से आगे बढ़ते हुए हम लोग चलते हैं, थोड़ा सा जानकारी लेते हैं कोल और बेस लोड जनरेशन के बारे में। हमारे बीच मौजूद हैं श्रीमती अरुंधति मुखर्जी, जनरल मैनेजर C&I फ्यूल मैनेजमेंट MTPS दामोदर वैली कॉरपोरेशन, और आज उनके प्रेजेंटेशन का टॉपिक है लीस्ट कॉस्ट decarbonization strategy for DVC MTPS, coal from base load generation to system insurance. Madam, over to you.
All the dignitaries present here. Today, I'm going to present a story to you of transformation of the role of coal. I'm Arundhati Mukherjee, GM Fuel Management from MTPS, the least cost decarbonization strategy for DVC, MTPS. Now we see that in April 2026, our government has revised the NDC targets, and so in this situation where the energy sector is in an inflection point, we are here to address that is a triple constraint problem, which we have to address not one by one, but simultaneously. Now, what are the three triple constraints? That is due to the changing demand profile. Now, the peak demand is growing rather than the average energy factors. And also there is a carbon constraint and also the market signals. There is a volatile market of RTM and DAM. So what are the three constraints? This is the constant of reliability, of sustainability, and affordability. In the context of India's energy transition, we see a rising energy demand, coal's dominance, and one more interesting thing is happening, that is the paradigm of base load in coal is under pressure. So what is the strategy that we will be taking? We know that DVC is an intensive, coal-intensive power portfolio, having a coal-intensive power portfolio. It is very crucial for grid reliability, supplying a large share of electricity generation in the eastern region. So our focus will be on flexibility, reliability, and resource adequacy. So here I have utilized the operational data and the marginal abatement cost curve for identifying the optimal pathways for the least cost decarbonization, or rather profitability for DVC. Here we find that the coal is redefining, we have to redefine the coal's role. How? Let us see. Now here it is the abatement option analysis. This is the marginal abatement cost curve. The y-axis is here, that is the cost for abatement of 1 ton of carbon dioxide. And in the x-axis, we have the cumulative carbon dioxide abatement annually for the different technologies that we will be using, or rather intermittents we will be using. So here we see that the thing is that MTPS, in the left-hand side, you can see that efficiency and operational optimization, operational efficiency increasing or operational optimization, then your flexible retrofits and ramping retrofits, we are having it on the negative side. That is, we are also decarbonizing, and at the same time, we are saving on the cost. And in the middle portion, you can see that we can see it is a system level enablers. The left side was operational levers. The second is the system level enablers, that is battery storage, which will be integrated with the renewable energies, and the biomass co-firing. Biomass is much costlier than coal, and so we have kept it here in the system level enablers. And the future technologies that we will be adopting will be the green hydrogen and CCUS, which are cost effective and which is more costly. And I have not included the nuclear here because SMR, the SMR market will be scaling in around 5 to 10 years. And the left side, you can see the carbon cost, 1,000, 2,000, 3,000. So even if the carbon cost that is in the upcoming CCTS market, though our power sector is not included in there, but in the near future, it will be included. So even if the carbon cost rises to 3,000, Media will be in a position to save cost and at the same time decarbonize if we have an efficient optimization strategy. Now, the conceptual framework here is transition to flexibility scarcity. How now the situation is that we are not sitting in an energy scarcity region, but in a flexibility scarcity region. It is not like that we are now the coal plants, the thermal power plants are not marathon runners, they are sprinters. So what is the thing is that we have to emphasize on the efficiency improvement, and whatever thermal fleet we have to optimize our efficiency, operational efficiency. So the potential abatement levers for MTPS within our plant are, from the analysis of the financial year 25-26 data, we see that we can have the drivers or the levers for abatement. Potential abatements are heat rate improvement, APC reduction, and coal quality optimization, and digital technology adoption for digital optimization. Now, let us see the real-time and day-ahead market here insights, what we get from here. This is a very interesting picture of us on the 6th May that we see that, and it is ultimately it is going to be a day-to-day features that we see that it is ranging from 0.25 kilowatt in the dam at noon to 10 kilowatt per kilowatt hour by night. And here 3.28 gigawatts of storage bridges the India's evening grid. So we see that now storage is not an optional anymore. Storage has to be integrated in our smart grids. And we have to make it a part of our functioning, and India has to adopt in the long run. This is a signal you can see. This is a graph you can see of the dam on 6th May and the RTM for the last 31 days average. You can see what is the thing, that the range, again that price is ranging from the 0.25 kilowatt from 0 to almost 10 rupees, 4 to 10 rupees in the evening hours. So here we see that from the insights from DVC market transaction data and the AGC data, we find that the energy trades fluctuate, exposing MTPS to market dynamics, energy revenue volatility, and also we see that we can earn from the AGC, automatic generation control, that is our secondary reserve SRAS by ancillary services, because it is revenue decoupled from the energy quantum. But if we are complying with the things that are complying with the signals of the AGC, we will be gaining in this range. So energy revenue is volatile by design, but flexibility revenue is stable by regulation. So future coal sustainability depends on now upcoming CCTS market and its impact on our thermal power plants or DVC or MTPS. We are in the PAT cycle now, so we are having efficiency audits and all those obviously audits, but we have to move from emissions per output. The thing is that we have to be operational efficiency is always there, and accordingly we have to decrease our carbon intensity, emission intensity. So the carbon adjusted merit order under CCTS will be effective cost will be variable cost plus carbon price into emission intensity. So efficient MTPS units will remain dispatchable even with the rising carbon prices, as we saw in the MAC curve. So tariff and O&M strategy for implications for DVC. Previously, the old paradigm was that revenue is equal to energy into energy tariff. But now we have to, in the coming days, we have 3 parallel streams of revenue, that is energy margin plus flexibility revenue plus carbon adjustment. Now rethinking coal contracts. Now we see that how we intelligently use coal will be the game changer. So coal's role is transforming from a base load to this. So we recommend the coal sourcing strategy for MTPS at FSA coal, 50 to 60% for stability anchor, DVC's own mines, flexibility and blend control, and 10% for domestic coal for the seasonal variations. Now for innovation in real-time GCV mapping and AI-based combustion control. This is we can bring to our coal plant. CHP, coal handling plants. That is why variable GCV, because variable GCV is not the problem, poor visibility is. Static GCV and manual blending ratios, reactive boiler tuning does a lagged response. We have to move from this to real-time GCV mapping. What it actually does, online core analyzers will be there in the belt-mounted, chute-mounted, and it will give us the data of the GCV, the VM, and the moisture content, and we can AI-based interfacing from combustion signals will give a coal quality map, live coal quality map. So how this will enable the efficiency, that it will be stoichiometric, we can control the air and be continuously optimized, excess air losses can be reduced, and outcome will be a stable combustion, and also unburnt carbon can be controlled and better boiler efficiency will be there. So smarter blending will be there, not average blending. And after this implications of the on-time, real-time GCV mapping and AI-based combustion control, we can have real-time coal quality data, GCV reason tracking, and stable bunker GCV, automated SCR operation, and improved boiler efficiency. So on-built coal analyzer, online GCV mapping, will bring an intelligence to how we handle coal. So key takeaways are there. The least cost decarbonization strategy for DVC MTPS emphasizes coal's transformation from a base load generation to a flexible system insurance role. The key takeaways include prioritizing efficiency improvements, leveraging carbon credit trading, adapting to market volatility, enhancing operational flexibility to ensure grid reliability. And so, with all these things, with the intelligent coal handling, we will be able to meet the triple constraint of reliability, sustainability, and affordability. Thank you.
Very good presentation. And this coal handling system, starting from loading, transportation, unloading, and handling at powerhouse up to feeding of coal to the coal mills. There are lot of scope for improvement, and if we reduce a we work on if we can reduce the kilocalorie, then it is the most, this will also add as a green initiative. Because we need efficient operation of thermal plants. Nowadays, thermal plants are not thermal plants. We can tell these are flexible thermal plants. So that when we need load, the plant should be capable of feeding the load. If you can go to this 6th May slide, this presentation, this 6th May. What happened on 6th May? You told everything.
Which one?
6th May, this
6th
load.
May, okay, huh.
Because we are discussing a lot of things about BESS.
Yeah.
But here, the contribution of BESS can be seen. So I want to show the audience also.
Show it on the screen, please, IT team.
IT cell. IT.
Yeah, it's visible, ma'am.
This, you can see, this around 3.28 gigawatt storage. The price was 0.25 and suddenly it went to 10 rupees. And you can see this discharge of battery. 3.28 gigawatt. It was perhaps from Greenco contributed 1200 and this THDC.
Yeah.
So the future will be of storage. So we have to work hard on this BESS system, and Mijia is doing excellent job. Nowadays we are getting full power, full load on the unit whenever required. So, thank you. Nice presentation.
वेरी गुड प्रेजेंटेशन. ये बताइए अरुंधति, हम लोगों का एज ए ईडी ऑपरेशन एवरीबडी यूज टू टेल दीज थिंग्स. सर, क्वालिटी ऑफ कोल इज नॉट अप टू मार्क, दैट्स वाई जनरेशन इज नॉट एट द ऑप्टिमम लेवल. संजय शर्मा का हमेशा कंप्लेन आता है कि सर कोल क्वालिटी के चलते बोलता है कि जनरेशन लॉस इज देयर. वन थिंग. सेकेंड थिंग, कि योर प्रेजेंटेशन इज गुड. And I have also seen the lot of the improvement has taken place after MTPS so far the coal management is concerned, yard management is concerned.
Yeah.
हम लोग we used to take 10 to 12 million metric ton coal at MTPS. So I would like to tell you two things. Yeah, that is AI or IoT management. We are going to adopt the real-time GCV measurement at MTPS. We are going to start right from MTPS. So can you assess that when the coal used to go from the belt conveyor to the bunker, that is real-time management of the GCB, real-time measurement you cannot carry out in the bunker. There is no any provision. So for the operational excellence as well as the operational optimization, it is our duty and best, because MTPS consists 1/3 of the DVC, to save the coal. And on the just previous day, 3 to 4 days back, we were striving to down the load because the power was selling at the ₹0 on the 1st of May. But we could not reduce the load due to the better quality of the coal. Yeah. So actually all the efforts is to be made for the proper judicious blending of the coal, especially.
Coal at feeding we can also
yes.
In the meal wise.
Yes.
So
yes.
that we can, the flexibility is there.
Yes, so I want to get, we all, not myself, we want to get the assurance from your end that right from today, the loss of the generation should not be on the account of the quality of the coal.
Yes, sir.
Can you assure us?
Best, sir.
Thank you.
Thank you very much, ma'am, for your proposed strategy. For kindly stay back, please, ma'am. Thank you very much. I request the esteemed session judges to present Mrs. Mukherjee with a warm note of appreciation for her proposed strategy for Megia Thermal Power Station, DVC's thermal power station with the largest installed capacity. Please put up a big round of applause for Srimati Arundhati Mukherjee. Thank you, ma'am. Thank you, session judges. The next paper presentation lined up in this segment is on the topic R&M MTPS Unit 1, 2, and 3. And for this presentation, I would like to invite upon the dais Mr. Sameesh Sharma, General Manager, NTPC Consultancy Wing.
Good afternoon, sirs. Respected session judges, Sri Sasa, AD Operations and AD Commercial, Sri Sanjeev sir. Respected senior officers from DVC, Member Technical Panda Sahab and other seniors. Other members from Indian Power Sector, on behalf of NTPC, I welcome you all. This presentation is a presentation, it's a perfect example of joint working of NTPC and DVC team. This is regarding DVC Media R&M DPR. This was, I can say, one of the first of its kind data-driven R&M DPR, which we started in December 23. And this was carried out by a team of NTPC and then present team. And it's a really a present coincidence that the person, the leader, the guide at that time from media, sir is now there as AD Operations. We did this R&M work there under the guidance of Sasa. And almost we completed most of the data collection and major report preparation by June 24 as per the target. But then few RL reports were pending. So we completed this in March itself this year. So now that report is submitted and R&M schemes worth more than 2,000 crores have been identified after due discussions and all the data collection. We completed this DPR preparation with the following R&M objectives, like we do in our NTPC also. We select R&M schemes based on these fundamentals. Means first, it should be on safety environment, then second criteria should be reliability improvement, and finally energy efficiency. So most of the time, safety, environment and reliability takes precedence over efficiency improvements. For the preparation of this DPR, we went to DVC site in December for 1 week discussions, and there we analyzed, collected 5-year operational data, then all the other reports like condition monitoring, DGA, oil and cess, everything, condition monitoring reports. Then we visited almost all the areas of media stage 1, means unit 1 to 3. We were all, we have domain experts from all the fields, turbine, boiler, electrical, C&I, civil, AHP, CHP. So we visited all the area and did a detailed study. Then we sat with the working level teams and senior management team there, and we completed this complete data analysis and report preparation by almost March, means next year. Then in the intervening period, we completed performance evaluation test during 3 visits. I came in for that February, and while coming that I visited DVC headquarters also for a senior management team guidance on that. In March 24, I was here in DVC headquarters to have further guidance on this DPR work. And then in April, we did almost 4 or 5 MS team meetings with all. Purpose of how we, I will show the recommendation, how we arrived to those recommendations. So what was the process, how intensive discussions and data analysis we completed along with the DVC team. So then in March, means April, May, we completed almost 4 or 5 MS team meetings with all, means HP, CHP, turbine, boil, water system, cooling towers. And then almost by June, we completed almost all the report part. So now I will show just a glimpse of recommendations. Of course, those all are prepared with a lot of discussion. So all cannot be just a glimpse. For that glimpse, I will share. This is basically the first page of that report. I am not showing report here. It is not move. Come down. So for this report, we completed, means we did almost 5 visits to complete the performance test. And these are the area wise. Just for the info of all the present here. In the boiler area, major recommendations were related with the mills, means mill R&M, a lot of performance decisions were observed. Then mill inerting system renovation, SCAF replacement, eco header replacement, then replacement of reheater, platen superheater, replacement of HRS, FSH headers and MSH and SRS power plants. ASLD is not available here, so we recommended ASLD for early detection of boiler tube leakages. Then APH replacement, likewise. Then ID fan transmission from Wyeth coupling to VFD motors. A lot of insulation improvement is also recommended. Then in turbine area, we have recommended HP, IP and LP rotor replacement or rotor chain. Then LP heater, manual isolating valves and all those things. Vent condition in one of the deaerator. HP bypass valve with the replaceable speed control valves. Then ceramic blanket pad and switch for turbine, replacement of CPs, installation of mechanical seals in CPs. Then BFP cartridges, MSL pipelines from DM makeup to hot well. BFP reciprocating valves are on-off type. So now these days we are using modulating type. Then VFD in CP. In one unit, VFD was already placed. So this is recommendation for other 2 units. And the critical piping replacement as per the RL reports. In the CW pumps, lot of flow variations were there. So that the replacement has been suggested. Then online vibration monitoring system has been recommended. And then all this intake water pumps, water ash water makeup pumps, auxiliary cooling water systems, all has been recommended. Then in cooling tower, FRP gets support for PVC rebar fills. Then SS fan drives have to be replaced with carbon fiber. The purpose so that is how studies and discussion done with the DVC team. Then FDPS, complete renovation, inert gas system for each control room. These are the major systems. Then complete compressor system replacement. Now there are reciprocating compressors, so this has to be replaced. Cooling water system for to be replaced. In CHP, paddle feeder support structures, elevators, fires, everything we have covered. Means every corner of the media 1, 2, 3 we have covered through this study. Then dust suppressor system in CHP, ash handling plants, bottom ash hopper refractory change, ash water pumps replacement, eco-SI within bottom ash area to be replaced with cost basalt. Then C&I, already DCS work is going on, so not recommended there. And in the RC structures based on the RA reports of IIT and Guwahati. And major benefits is expected on these: improvement in availability and reliability, reduction in generation loss, oil consumption, heat rate, APC, better operational flexibility, easy maintenance, better CHP utilization, and advanced automation. So this is a very good report, means all person, and this is first of its kind, so probably it may be replicated by other GENCOs also. Recently we are in discussion with RRM for quota R&M also. So that we may do after that. So this is all from this. This we presented as a mark of our means functioning with DVC team. So this is a good example to follow. So with this, thank you, sir. Thank you, DVC team, for giving this opportunity to NTPC team. So we have completed this. Thank you, sir. Just for the information, we are doing a AI project on this. What we did in DVC, now we are doing AI project on R&M scheme identification based on data only. So every data, every report we will place, and I am the project coordinator for that also, and we are doing this triple ITNR. AI project here, and we are going for this Simhadri project. Simhadri will be due for R&M in 28-29. So at the advanced preparation, and by July, August, that model will be prepared. And if it is prepared, that will be really a good thing for all power stations. So means we feed the data, and a scheme prioritization will be available for senior management to decide which will be the best for that plan. Okay, thank you, sir. Thank you.
Thank you very much, sir. And now I would request our esteemed judges to kindly felicitate Sri Samir Sharma, GM NTPC, with the token of gratitude and appreciation. Huge round of applause, audience. Thank you. MTPS 1, 2 and 3 are the oldest units of Mejia Thermal Power Station, and they commenced commercial generation in 1997-99, years 1997-99. And now moving forward, हम लोगों के बीच आज मौजूद हैं श्री दीपक कुमार सिंह। हम सभी लोग जानते हैं कि किसी भी थर्मल पावर स्टेशन में, किसी भी थर्मल पावर प्लांट में ऐश हैंडलिंग सिस्टम की क्या इम्पोर्टेंस है और ऐश डिस्पोजल कितना इम्पोर्टेंस रखता है। तो आज हमारे बीच में मौजूद हैं एनटीपीसी कॉर्पोरेट ऑफिस रायपुर से श्री दीपक कुमार सिंह, एडिशनल जनरल मैनेजर कॉर्पोरेट ऑपरेशन सर्विसेज, बैलेंस ऑफ प्लांट, और वो स्ट्रेटेजिक इवोल्यूशन ऑफ ऐश हैंडलिंग सिस्टम्स इन एनटीपीसी फ्रॉम वेट डिस्पोजल to advanced dry technologies for sustainable and compliant power generation पे आज हम लोगों को अपना presentation देंगे। दीपक सर, over to you.
Good afternoon, respected session judges, dignitaries, distinguished delegates and colleagues. I am Deepak Kumar Singh from NTPC Corporate Operation Services. Today I would like to share a transformation journey not merely of ash handling systems but of how NTPC converted an environmental challenge into a sustainable operational strength. This journey reflects how green initiatives and thermal excellence can successfully coexist in coal-based power generation. Typical ash distribution in coal-based thermal power plant is bottom ash around 20%, eco APH and duct ash around 10% and ESP ash around 70%. Coal-based power plants in India operate under very challenging conditions. High ash Indian coal, stringent environmental regulations, water scarcity, land limitations for ash disposal. Traditionally, ash handling systems were designed mainly for safe disposal. In earlier wet systems, ash water ratio were as high as 1:10. This means high water consumption, large ash pond, low ash utilization and high environmental footprint. NTPC started its transformational journey in early 90s. NTPC's ash handling evolution happened in 3 phases. Phase 1, wet system. Initially, the focus was on safety and reliability. Hydraulic systems transported ash using large quantities of water. These systems served the purpose during the early years of power generation, but gradually the limitations became severe. Phase 2, then came the transition phase, that is hybrid systems. NTPC introduced pneumatic fly ash conveying, separation of fly ash and bottom ash, partial dry evacuation systems. This significantly reduced water usage and improved ash utilization. Adoption of SCSD system further improved ash water ratio. But the real transformation came in next phase, that is phase 3, complete dry systems. From projects like Patratu onwards, NTPC adopted fully dry fly ash system, that is ESP ash, eco ash, APH ash, duct ash, all evacuation only in dry mode. Then next, dry bottom ash collection. World's largest dry bottom ash system commissioned at Patratu. Now, dry evacuation in all stream is achieved. This was a major shift from disposal-oriented system to sustainability-oriented systems. The vision became elimination of ash water usage, reduction of ash dike dependency, movement towards zero ash pond concept. This was not only an environmental decision, it was also a strategic business decision. The latest system, that is dry bottom ash system, bottom ash of around 1000 degrees centigrade is collected on a metallic conveyor. Air is used for cooling instead of water. Temperature reduces to around 120 degrees centigrade before conveying to ash silos. This resulted in zero water consumption, better ash quality. This demonstrates NTPC's futuristic approach toward sustainable thermal power generation. But this transformation journey was not easy. Indian coal conditions are extremely challenging. During the transition from wet to dry system, NTPC faced issues like ash pipeline leak. Percent of non-pit head stations, these problems became even more severe under variable coal quality and multiple mine supplies. At one stage, it became clear standard design alone would not solve these problems. Real success came through continuous site feedback and engineering improvements. NTPC implemented several engineering interventions. System improvements include additional transport airlines, double branch operation, improved coarse ash evacuation by enhancing sizing, vacuum pump capacity enhancement, and material of construction change, improved wall material of construction, silo vent fan capacity enhancement. But equally important were O&M practices. Across NTPC stations, standardized O&M practices were implemented. Daily shut-off vacuum, checking and operation within the design vacuum range, drawdown mode de-ashing of bottom ash once in 24 hours, ash pipeline thickness monitoring and rotation replacement and rolling plant implementation, temperature monitoring of bottom ash hopper, eco hopper outlet pipes, dry ash lines. Preventive maintenance scope and schedule was standardized. Digitalization and smart monitoring have strongly supported NTPC's transformational journey, capturing all critical ash handling parameters and developing consolidated dashboard for monitoring and early fault detection. These practices significantly improved reliability, availability, and performance under high ash coal conditions. One major learning from this source, NTPC has installed ash byproduct plants and promoted production of ash bricks, interlocking wall blocks, lightweight aggregates, nano concrete aggregates, geopolymer products. This reflects a true circular economy approach, where waste is converted into value. The journey is still continuing. Future systems and digitalization. NTPC is still adding thermal power plant capacity. Around 19,000 megawatt is under different stages of tendering. Future projects from Talcher 3rd onwards include ash classification systems, ultra fine and fine ash separation and collection as per IS 3812. This will improve ash quality, market value, and utilization potential. NTPC is also moving towards AI-based predictive maintenance, advanced pattern recognition system for early identification of deviation, digital monitoring dashboards. The future vision of ash handling is fully automated dry ash ecosystem with minimal environmental footprint. Now to conclude, NTPC's transformation from wet to advanced dry ash handling system is not merely a technological upgrade. It is a demonstration of sustainability, innovation, reliability, environmental responsibility. This journey proves that green initiatives and thermal excellence can successfully coexist in coal-based power generation. And perhaps the biggest takeaway is this: with continuous innovation, even a traditional challenge like ash handling can become a strategic strength for sustainable business operations. Thank you.
What mode you have adopted in NTPC for 105% utilization of the pond as? That is for what mode of transportation you have adopted?
Major portion is going in road construction. Around 50 to 60% is going in road construction. Rest 40% in cement industry as well as the production of building materials, as I have shown.
Okay, the road either you are sending to road project that is high NHI, RCR mode or through road transportation. Rail, road rail, or what mode of transportation?
Major is road transportation.
By road?
Major portion is going road transportation. Exact data I don't have, but major portion is going through road transportation.
Up to how many kilometers?
300 kilometers. 300 kilometers.
Up to 300 kilometers, you are giving them free of cost?
No, it is not free of cost. It is governed by the policy of government. It has different steps. First, you try to auction the ash. If somebody is not taking, then to give free and then bear the transportation.
Yeah.
So all the three modes.
Have you got any successful bidder through the auction that they have offered some price?
Yeah, we are getting.
Some price?
We are selling from 0 rupees to 600 rupees. Different from different to different plant. It varies from different to different.
Dry you are selling or pond?
Dry, especially dry ash.
Thank you.
I have a question. You were telling that you draw down bottom ash. That means bottom ashing, as we say. Is it done once in a 24 hours?
So there are two modes of bottom ash. In water impounded system, two modes of doing bottom de-ashing.
No, I'm talking about dry bottom ash.
No. In dry bottom ash, the system is continuous.
Continuously
Continuous metallic chain.
And for that, you will be having a 24 hours running of a fan.
Metallic conveyor.
For getting it cool. Have you checked that the auxiliary power is getting impacted because of this fan running for 24 hours? Have you checked it?
Auxiliary power is, in fact, sir, entire plant ki auxiliary power is less because we are not using any water, we are not using any dye, and this air for cooling the ash is used in a combustion. It is 2% of the total combustion air. So designer says that we improve 1% in boiler efficiency.
Okay. So that means this air is getting recirculated.
Yes.
Thank you.
Thank you, sir, for your presentation. Ladies and gentlemen, this is the kind of quality conversations we are looking forward to, and I request all of you to pay heed to all the sessions so that you can gain the maximum out of this O&M conference. Thanks once again. I request our esteemed session judges to present our presenter with a token of honor and appreciation from our end. Please put up a round of applause for Mr. Deepak Kumar Singh for his presentation today. Our next presentation in this segment is on the topic Technical Session of TLT Design Axial Fans and Possible Upgrade. To present this, I would like to invite upon the dais representative from Messrs. TLT Turbo India Private Limited. Meanwhile, I would request our team to kindly flash the QR code on the screen from time to time so that our esteemed delegates can put in their valuable feedback and suggestions. Thank you.
Good afternoon, everyone. First of all, I'd like to thank the DVC team for giving us the opportunity to present us in such a knowledge sharing event where we can discuss some knowledge sharing discussions which we are implementing or going to implement in the DVC different plants. My meeting agenda is TLT Turbo India operations, TLT working with DVC plants, which we are doing for the past 10 years from 2016. TLT India initiative Make in India and localization, which we are going to do for DVC plant.
Hello. Please switch on your mic. Please, you're not audible.
Mic is on. Hello. Now it is audible, sir? Okay. Failure and breakdowns analysis, preventive maintenance technique. ये स्लाइड में हम लोग दिखाने वाला है जो हमारा टीएलटी का जो बिजनेस स्ट्रैटेजी, टीएलटी इंडिया, प्रोक्यूरमेंट, डिज़ाइन, प्रोजेक्ट मैनेजमेंट, project documents, quality assurance, logistic, which are going to handling by TLT India itself. And FSPT, which is our the latest technology. Let me say that which we did at the BHL Ranipet plant with joint venture with BHL, and the rotor engineering which to be approved from TLT Germany for any type of rotor engineering, and also the drawing approvals. In this slide, FGD booster project which we have executed till date now, KPCL, YTPS, DVC Bokaro. DVC Bokaro means FGD booster fans, MB Power, GSCCL, Sikka Tips, Rihan, Simadri, Talcher, CGPL Mundra, Jojo Vera, Prayagraj, Rihan, Dusan, and there is mentioned that their install capacity also. ये स्लाइड में डीवीसी प्लांट का पूरा डिटेल्स है. फॉर दैट वी आर वर्किंग विथ डीवीसी टुगेदर in their joint venture also, or supplying the spares or HADs or any rotor parts, rotor components, rotary parts, I mean to say. This is our new aerodynamically optimized suction box designed by TLT India. This is our latest technology which we have developed according to TLT Germany design guidelines. This is only for reference only, sir. Mainly this is for upgradation purpose. Not only for the BHL units, we have also done for reverse engineering of third-party fans like Suen or SRB, Shanghai blower, Senian blower ventilating, Howden. They are also included with the upgradation. And TLT Turbo India initiative for Make in India localization for the optimization of pricing or costing, and also the dependency from the TLT Germany also to reduce the lead time and the cost effectiveness. I'm just skipping these slides. Modernization and upgrades, which is the latest technology which are going to invented for DVC exclusively. For reason for modes and apps, mainly increase the efficiency or fan performance, adaptation of the fan performance to the existing situations, optimization of the fan efficiency, energy saving, easier maintenance, less plant shutdown, plant modernization, use of change raw materials, majorly the defects for the coal change raw material, and axial fans with variable blades, change of blade material, FD and PA fans only, change of blade material, change of blade profile, dismantling of blades or second stage fan, change of rotor, different half size. On the different half size, we can do the upgrade as per the customer requirement, and if required from the plant to increase the efficiency only. Installation of control system and silencers. That is the modes and apps. This is one of the example of second stage AP fan upgradation which we have done for Malaysia project. In Malaysia project under the TLT Germany order executed from TLT India itself. And the fan model will be AP2 31.20. The main reason for this upgradation is required that the efficiency was the fan on the existing foundation which found was 50%, and after the upgradation that found up to 70% efficiency. And this happened on the only existing foundations only. Changing the blade, changing the rotor and blade profile. Hydraulic adjustment device, that is our latest technology which we have developed. Actually, HAD is the heart of the rotor assembly. In that part, we have changes the setting shaft assembly, change the positioning of the mechanical item, changing the positioning of mechanical item which could failure in the several time. So we upgrade under the TLT Germany design that the second part for setting shaft assembly can be replaced easily to get the better efficiency for the HAD life. And this is under the G2.5 hydraulic adjustment device. Stalling warning unit. I would like to call our service engineer, Mr. Ashok Bisa. He will be explained better for the next slide also.
Hello. This is a stalling device. A PFN and FD फैन के लिए बेसिकली इसको हम लोग इंस्टॉल करता है. तो ये ऑलरेडी हम लोग टाटा, CGPL, मुंद्रा एंड अदानी स्टॉलिंग डिवाइस ऑलरेडी किया हुआ. इसमें वॉल्यूम एंड प्रेशर ये सब देख के इसको फैन को तुरंत बंद कर देता है. तो ये स्टॉलिंग डिवाइस बेसिकली प्रोटेक्शन करता है PFN स्टॉलिंग के लिए. तो ये जब आगे के लिए जाता है तो ये है हार्ड फेसिंग एंड हमारा PU कोटिंग. PFN एंड FD फैन के लिए PU कोटिंग होता है. इसको लॉन्जेविटी 3 and 4 years इंक्रीज करता है. और ID फैन के लिए हार्ड फेसिंग, इसको GG मॉडल में जितना भी हमारा ID फैन है उसको एज में ये कोटिंग अगर किया जाता है तो ये इसको आगे में हमारा मिनिमम 1 years का लाइफ और भी बढ़ जाता है. ये हम लोग ऑलरेडी किया है CGPL, मुंद्रा एंड अदानी में. वर्कशॉप के लिए हम लोग को जो बेसिकली हम लोग जो फॉलो करता है उसको क्या है, हमारा लूवाइल स्किट का, इधर कूलर का, मैनुअल का, जितना भी हमारे MBA का जो लीकेज वगैरह होता है इसको ऑलरेडी हम लोग बहुत जगह ये सॉल्व किया है. तो ये हम लोग आगे में इसको और भी बेहतर तरीके से हम लोग अभी कर रहे हैं. कॉस्ट स्लग, ये HAD फेल्यूर का सबसे बड़ा एक कारण है स्लग के लिए. ये ऑलरेडी मैक्सिमम यूनिट में ऐसा ऐश ऑलरेडी रहता है. HAD फेल्यूर का सबसे मेन कारण है. इसको हम लोग सॉल्व कर रहे हैं. बैरिंग फेल्यूर में जो मॉइस्चर है, ये मॉइस्चर के लिए सबसे ज़्यादा बैरिंग फेल्यूर होता है. वो ऑलरेडी हमारा कुछ यूनिट में ऐसा दिखाई जाता है. स्लाइडिंग ब्लॉक डैमेज बहुत सारा BHL का यूनिट में है, वो सिर्फ NTPC का यूनिट में हमारा दिखाई देता है. स्लाइडिंग ब्लॉक डैमेज हो रहा है, ये भी इसका एक कारण है. जितना भी स्लाइडिंग ब्लॉक है, ये स्लाइडिंग ब्लॉक का जितना हमारा जो आगे में मटेरियल है इसको हम लोग चेंज किया है, अभी ऑलरेडी जो भी फीडबैक है वो बेटर कंडीशन में मिल रहा है। और सप्लाई करने के लिए अभी जो हमारा टेस्टिंग वगैरह है वो टेस्टिंग हमारा बेहतर तरीके से उसको करके हम आगे में हम लोग फिर वो स्लाइडिंग ब्लॉक को अपडेशन किया है, वो अभी जहाँ भी रिपोर्ट है वो बेटर रिपोर्ट अभी हम लोग को आ रहा है। थैंक यू सर।
बहुत बहुत धन्यवाद सर। अब मैं हमारे स्ट्रीम्ड सेशन जजेस से निवेदन करूंगा कि वे कृपया हमारे प्रेजेंटर को फेलिसिटेट करके अनुग्रहित करें। जोरदार तालियों के साथ और अब आगे बढ़ते हुए हमारे साथ TKIL इंडस्ट्रीज़, जिसे कि पहले थाइसन ग्रुप इंडस्ट्रीज़ के नाम से भी जाना जाता था, आशीष बर्तवाल AVP और श्री विनोद सिंह जनरल मैनेजर हमारे साथ मौजूद हैं और उनका टॉपिक है आज परफॉर्मिंग टू पोटेंशियल TKIL अप्रोच फॉर ऑपरेशन एक्सीलेंस थ्रू 360O सर्विस।
Good afternoon, gentlemen. My name is Ashish. I represent TKIL Industries India Private Limited. Earlier we were called Thyssen Group. Along with me, Mr. Vinod Singh is there. So in today's session, we will be discussing certain digitalization solutions and the initiatives that we have taken through our learnings in executing operations and maintenance contracts, basically for coal handling plants and material handling systems. So this is a brief description of our company. We are basically a EPC company. We make sugar plants, we make small boilers and waste heat recovery power plants. We make bulk material handling systems, cement plants, and we do provide services to all these industries. In past 2-3 years, we have ventured into green hydrogen, battery and energy storage solutions and CBG plants. So now coming to the digital solutions that we have made. Now see, these digital solutions that we have prepared, they come from our experience in doing O&M contracts for coal handling plants and material handling systems in power plants and steel industry. So typically what we have seen in a material handling systems, a large number of manpower is deployed for monitoring conveyor belt systems. These are basically conveyor operators who are stationed in transfer towers. If you see functionally, they are not operating the plant. Plant is typically operated from control room, but they are stationed there just to monitor if there is any abnormality in the belt systems and respond to it. Now, see the cost of these people who are deployed on 24-hour basis is a significant component, and every management, all the customers that we have met, they look forward for reduction in people. So this is a smart cabin solution that we have prepared and implemented it for one of our customers in the steel industry. So there are two dimensions in it. One is a CCTV system, which is a very basic, simple CCTV system wherein we install cameras at various strategic locations, and then this operator sits in a small control room. This small control room is like a small cabin we see for a security guard kind of thing. This can be placed in a transfer tower at any corner. अभी होता क्या है, इसमें ये जो ऑपरेटर बैठा है ये सीसीटीवी फुटेज देखता रहता है, एंड नाउ अ सिंगल ऑपरेटर कैन मॉनिटर 4-5 ट्रांसफर टावर्स. सो दिस विल रिड्यूस, अगर आपको एक लोकेशन पे 5-6 ट्रांसफर टावर ऑपरेटर्स रखने पड़ते हैं, यू कैन रन इट विद वन ऑपरेटर एंड मे बी वन मोर ऑपरेटर इन द फील्ड. सो देयर इज अ रिडक्शन इन मैन पावर. So this is a basic CCTV kind of a system, nothing sophisticated about it. इसका जो अगला dimension है, that is a machine learning dimension. Now that is important and interesting part of it. So what happens is the video feed from the, see what the operator is doing in a transfer tower is there to see if there is a sway in the belt, if there is a blockage, if there is a spillage, इधर उधर से कोयला गिर रहा है, वो सब देखने के लिए operator वहाँ पे बैठा है. Now if we can digitalize, am I audible? So now if we can digitalize it, if we can put these video feeds in a AI machine learning kind of a scenario, the computer will be able to detect a belt sway, computer will be able to detect if there is any pileup, and the computer will be able to detect if there is any chute blockage or something like that. So now the decision for taking a corrective action on such a situation is not dependent upon the alertness and vigilance of the operator. Computer does it, AI or a machine learning program does it with highly in a very highly efficient way. So this reduces the dependency on vigilance and alertness of an operator, and a corrective action can be immediately taken. A control room operator can be alerted. So this is the interesting part of this smart cabin solution. It's not a very expensive solution. The basic hardware involved are digital cameras, machine learning software. You can also integrate certain sensors which may be there in the system, like temperature sensors and vibration sensors, which also can be. So it is like a small control room for a transfer tower operator with digital AI enabled systems. So it's a small picture. You see this operator is sitting there. In this solution we have also given a start-stop of buttons, push buttons for the system, for the operator. So if he sees an abnormality and wants to respond to it, he can directly switch off the belt from there itself. Now coming to the next solution, this is, we call it IPCOM. Now since we are operating and maintaining several plants for our customers, the biggest nightmare that we are scared of is a long through cut in a conveyor belt. Especially if you are in a situation, say we were running a coal handling system for a pit head power plant which was fed by a 4.5 kilometer long belt, and it was a single line belt. So we were feeding a 1200 megawatt power plant with which was being fed by a single belt. Now the problem is we were always scared of getting a long through cut in a belt, and we had a robust system of people going and inspecting chutes, looking at the line plates, but there was always a risk of a liner falling on the belt and belt getting cut. तो हमारे एक पुराने साहब हुआ करते थे, वो बोलते थे कि जिस चीज़ के होने की संभावना है वो एक दिन ज़रूर होगी. So we had on a very bad day, one liner plate had fallen, and incidentally that liner plate was not the original OEM supplied liner plate. The liner plate was a modified plate, उसका size बड़ा था, वो नीचे बेल्ट पे गिरी और conveyor belt से पास नहीं हो पाई. So we had a long through cut. The through cut was 4 kilometer long, 4 kilometer belt was damaged, and it was not an easy thing to restore that belt. So eventually power plant had to be shut down for some time. They had to, they had 7-8 units. They put 4-5 units on a shutdown. And we felt like, no, this is not a situation, this is not the thing which we should be risk, which we should live with. Ek operator, see, at that point of time, if operator was vigilant, he would have stopped the belt. If operator was not there, he was somewhere else, and it took only 10-15 minutes to get a through cut. Now, we were looking continuously for finding a solution for such a situation wherein we can save our belts for getting a through cut. Now, this solution we have developed for mitigating this particular risk. Now, in this, what we do is we install digital cameras under the belt. Now, those digital cameras installed at strategic locations, they take continuously the video feed from the belt, and that video feed is fed to a AI-based program, and it is able to detect any through cut in the belt. So what happens is, if there is a through cut in a belt, you will not be depending upon the vigilance of the operator to stop the belt and preventing the damage to further escalate. तो ये सिस्टम क्या करता है साहब, डिटेक्ट कर लेता है बेल्ट को, थ्रू कट को, और बेल्ट के जो डैमेज है उसको रोक लेता है. This is especially useful if you are in a single belt situation, single line belt situation, and it's a very critical asset and it's a long belt. Okay, so I'll quickly go to the next slide. So here, this is a PDF slide you will not be able to see, but then these are small videos wherein the system is able to identify if there is any surface damage on the belt, or if belt sways or something like this happens, and the computer does it based on machine learning programs. Now, third part is this IP Copter. It's a comprehensive supervisory software that we have developed for monitoring conveyor belts. Now, what this system does, it takes data from the CHP PLC, puts it in a cloud through a very secure edge device. And this data, basically the key input data are data from VFD, speed feedbacks, power feedbacks, and feedback from belt loading systems, belt weighers. So this system का purpose क्या है sir? To give you a dashboard wherein you can see the overall analysis of the system. And one very important feature of this program is, like when we start the system, when we stop the system, lots of idle running is involved, especially if your CHP is like 4-5 kilometers long, 15-20 minutes तक idle running रहता है system, and this energy is wasted in it. See, अभी कोई operator belt शुरू करेगा तो वो feeding तभी लेगा जब last belt on होके पूरा आ जाएगा, and same thing, you'll empty the belt. Now this software keeps a track of how much material is available in which part of the belt. So based on that, it will automatically switch off the belts, which leads into energy saving. And if you are in a situation wherein you are not running your belts at full load, now in that case, this system is able to take a decision on reducing the speed of the belt. Say for example, you are blending a coal, maybe you have a 1200 TPH or a 2000 TPH system, और आप एक स्ट्रीम को चला रहे हैं 500 TPH पे और दूसरी स्ट्रीम को चला रहे हैं 1500 TPH पे. So this system will slow down through VFDs the 500 TPH system, and there will be a significant amount of energy savings in this particular things. And then there were some good O&M practices, but since we don't have time, so I'll skip it. Gentlemen, thank you for your patience and inviting us and letting us to participate in this. Any questions, sir?
Have you analyzed the reduction of breakdown or performance? I mean to say that the efficiency improvement by using the IoT or ICOM through the predictive maintenance. Have you carried out any case study?
Sir, see, this IoT and machine learning and AI is a very powerful tool. See, if you see the system that we have developed, which uses video analytics to identify belt trips, to identify belt sways and all, this is the area wherein, I mean, there are several other things that can be done through video analytics and AI. Say, for example, you can have a digital curtain, wherein, say, for example, you have a conveyor system and you don't want people to come close to it when it is running. So you can have a video camera which detects if people are coming maybe 1 meter close to it, and then
I
shut
mean
it down.
to say that is, you are carrying out the predictive maintenance through the IPCOM. IP-based camera. You have told through predictive maintenance, why we are using either digital tools or AI technology only to reduce the breakdown by judicious implementation of the predictive maintenance.
Yeah.
Have you carried out any case study of the any high energy consumption equipments or breakdown to reduce the breakdown of any thermal power station?
I can comment on energy consumption. So through this iCopter system, we implemented in a port, correct? So now in a port, you are in a situation where you're handling multiple cargoes. So sometimes you are handling a cargo wherein your TPH is high, sometimes you are handling a cargo where your TPH is low. So हम लोग energy consumption कर पाए by controlling the speed of VFDs. Say for example, आपको 500 TPH कैरी करना है बट आपका सिस्टम को कैपेसिटी 2000 TPH है. यदि आप इस बेल्ट को, मान लीजिए बेल्ट आपकी 3 मीटर पर सेकंड की है, यदि आप 3 मीटर सेकंड पे बेल्ट चलाएंगे, माल थोड़ा सा है बेल्ट में, बट यदि आप इस बेल्ट को 1 मीटर पर सेकंड पे चलाएंगे, बेल्ट भर के चलेगा और यू विल हैव एनर्जी सेविंग बाय रनिंग द ड्राइव्स एट लोअर स्पीड. हमने 20-25% एनर्जी सेविंग अचीव किया थ्रू आईकॉप्टर सिस्टम्स. बट उसमें लिमिटेशन क्या था, यू नीड अ VFD फॉर दैट.
Actually, you see everywhere what we have seen, that is the utilization factor in many good thermal power station is not more than 55 to 60%.
अच्छे सिस्टम में 70 तक जाता है सर. वी रन अ प्लांट वेयर इन वी अचीव एवरेज मंथली बेल्ट यूटिलाइजेशन ऑफ 70-72% in a system which is like built by us and maintained and operated by us. Say, I'll just go back. It's a petcoke handling system that we supplied for.
Our bone of contention behind the entire scenario is that the moment we shall go any type of the investment, definitely we shall intend to get the payback period.
Yeah.
That's why I'm asking you.
Sir, देखिए these digital tools from keeping considering I understand you're trying to come to the point wherein like what money is spent on these digital tools. So they're not very expensive, sir. अगर आप hardware की terms में देखें, they are digital camera, they're not expensive. And software and all, yes, developing these softwares is expensive. But then once you spread its cost to several installations, they are not very expensive. Okay, thank you, sir. Thank you for your time and thank you for your patience.
Any questions from the audience?
Sorry?
उसका जो कोयला का वेट से सैगिंग जो होता है, और जैसे बेल्ट पुराना होगा उसका एलोंगेशन बढ़ेगा, सैगिंग से उसका रेसिडुअल लाइफ प्रेडिक्ट कर पाएंगे क्या आपका ये?
देखिए बेल्ट लाइफ का अभी जैसे हमें IP कॉम का बारे में बात किया, इसको सोल इनपुट जो आ रहा है वो डिजिटल कैमरा से आ रहा है, करेक्ट? नाउ एक ऑपरेटर जो वहाँ पे खड़ा है वो आंखों से देख के डिसीजन लेता है. सेम थिंग वी आर रिप्लेसिंग दैट इंटेलिजेंस ऑफ द ऑपरेटर.
ह्यूमन जो कर रहा है सब आप कर रहे हैं, लेकिन उसका सैगिंग से लाइफ बेल्ट जब इलोंगेशन होने लगता है, इलोंगेशन बढ़ जाता है, लंबा होने लगता है,
वो हमने ट्राई नहीं किया सर. हम बेसिकली हमारा फोकस है बेल्ट स्वे को देखना, स्पिलिजेस को देखना और कहीं थ्रूकट लगेगा या
ह्यूमन का सब्स्टिट्यूशन
वो देखा है हमने. ये एक अच्छा इनपुट है सर. विल ट्राई टू सी हाउ वी कैन एड्रेस इट.
Thank you very much for your presentation.
Thank you, ma'am.
I now request the esteemed session judges to extend a warm note of appreciation on behalf of Damodar Valley Corporation to the presenter. And audience, please put up a big round of applause for this presentation on behalf of TKIL Industries. For those of us who have joined us, this was a presentation on performing to potential TKIL approach for operational excellence through 360-degree service. Thank you, sir. Thank you, esteemed session judges. Moving on, our next paper is an attempt on exploring clean fuels. And to present this, I would like to invite upon the dais Srimati Kalyani Pine, Senior Manager, Sri Shashi Chaudhary, Manager, and Sri Amit Chauhan, Manager from Mejia Thermal Power Station DVC to present on the topic Reimagining Coal Gasification Pathways in Damodar Valley for Clean Fuels. I request the presenters to kindly keep their presentations restricted to 10 minutes, We can always carry over the conversations and the discussions over the networking breaks. Thank you. Over to the presenters.
A very good afternoon to respected Chairman Sir, respected Member Technical Sir, respected CVO Sir, respected ex-Member Finance Sir, and all the dignitaries present over here. We are, myself, Kalyani Pine, Shashi Chaudhary, and Amit Chauhan feel privileged that we have been given an opportunity to present our presentation on the topic Reimagining Coal Gasification Pathways in Damodar Valley for Clean Fuels. Now the title very aptly suits today's crisis situation that is occurring in the Middle East. The global economy currently relies heavily on oil and natural gas. Recently we are facing shortage of liquid and gaseous fuel due to geopolitical issues. There is a growing need to transition to alternative energy resources to achieve self-sustainability. Recently, our Honorable Prime Minister in his address at Hyderabad said that to protect the citizens and to cope up with the Middle East crisis, India doesn't have the sufficient crude oil reserves, and we have to import. We are paying a high subsidy of rupees 3,000 per bag to the Indian farmers, 300 per bag instead of 3,000 which we are importing from the Middle East. So coal offers a variable option for transportation and gaseous fuel, reducing dependence on petroleum and natural gas resources from Middle East countries. We thought that coal could be a best option for the gasification that could have been taken as a major step towards clean fuel. Now moving on to the success story of the China, where we can see that China produces around 54% of the world's methanol capacity, and that is exclusively 70% of that is from coal. They are doing the methanol blending in fuel, now stands at the 21 MMTPA, whereas they are also producing around 30% of the world's ammonia urea, and 90% of that is derived from coal gasification. Now, what is coal gasification? It is basically a clean technology that converts the solid coal into gaseous fuel, syngas, mainly composed of carbon monoxide, hydrogen, CO2, and methane. Now, these gasification, the output gaseous fuel heating value also varies as we provide the oxygen supply. The high heat content has a heating value of 37 megajoule per meter cube and consists mostly of methane. This is basically the syngas. Now, coming on to the present coal scenario in India, around 400 billion tons of coal reserves are estimated by the Geological Survey of India, which are being found at a depth of 1,200 meters. In 2024-25, the total production of coal in India has risen to the tune of 1.04 billion tons. Now it is expected that coal will dominate with 48% in the projected share in the primary energy consumption by 2040. And also according to Niti Aayog's anticipated coal demand projection, for 2030, coal usage will be around 1.19 to 1.3 billion tons. Now we have the bulk reserves of coal, but the fact is that around 73% of this coal are inferior grade non-coking coal. with a high ash content of 45 to 50%, having a moderately high reactivity and high ash fusion temperature. So this is the area which we need to, which we have, where we have the market, and we can successfully utilize for gasification, reducing our oil dependency by 82% and our gas import dependency by 45%. Now, recently on 13th May 2026, just 3 days before, the cabinet approved an improved incentive scheme. Before this approved cabinet order, it was said that around 8,500 crores of financial incentive will be provided for the promotion of coal or lignite gasification projects. And now it is a pleasure to inform you that the incentive scheme have risen by around 37,500 crores instead of 8,500 crores, which will be a big deal for all of us. So each plant will be provided at least an incentive of 20% of the capex, or rupees 5,000 crore, whichever will be the lower. But in case of urea and SNG production, the incentive will be higher, as much higher as up to the tune of 9,000 crores. Now, the rest of the presentation, handing over to Shashi.
There are mainly 3 types of coal gasifiers utilized for gasification purpose. First is fixed bed gasifier, where the coal is fed as larger chunks and gas flows up through a packed bed, giving simple design and high thermal efficiency. However, it produces more torque and is less flexible for low-grade coal. Second one is fluidized bed gasifier, where crushed coal is suspended in upward gas flow, giving excellent mixing, uniform temperature, and good use of lower quality coal, as well as mixed feed. This gasifier operates below ash fusion temperature, avoiding slag formation, and does not require very fine grinding. And the last one is entrant flow gasifier, very finely ground coal carried with oxygen at high temperature, giving near complete and fast gasification. Overall, all these 3 gasifiers serve the same purpose of converting coal into clean synthetic gas. For Indian coal, because have high ash content, the poor coking properties, that's why fluidized bed gasifiers is the most suitable option. Fluidized bed gasifiers operating at about 800 to 1000 degrees Celsius keeps the temperature below the ash fusion temperature, so the ash stays solid and can be removed easily, avoid slagging and clinker problem. The good mixing also improves the heat transfer and helps gasify low quality mixed fuel efficiently. Another key advantage is cost. Fluidized bed gasifiers do not need very fine coal grinding, so both the operating and capital costs are relatively low. This slide highlights the proposed coal gasification project for the DVC Tibet coal mines required for the overall purpose. The proposed system in DVC is designed for the coal feed capacity of 2,000 ton per day. From this, we can expect syngas yield of 1.3 to 1.6 nominal meter cube per kg of coal, with coal gas efficiency in range of 70%, which is utilized as a replacement of LNG. The key advantage of this project is to convert low-value domestic coal into useful end products, reducing dependence on imported fuel and supporting cleaner and more efficient energy utilization. It also aligns with DVC vision of sustainable and better resources utilization. Here we can observe the DVC mining reserves. Out of 6 allocated coal mines, currently Tibet coal block is operational. However, DVC recently acquired 4 more coal blocks with substantial coal reserves. They are Mandakini B, Dhulia North, Tirupati Barahat, and Mahuagadi, providing further gasification capacity for the future.
The project proposed requires approximate capex of 6,500 crores. The calculations are made considering a subsidy of 15%, which, as already discussed 2 days ago only, have been increased to 20% capex support, up to 5,000 crores. the investment, this makes the investment way more lucrative. The gasification process is designed in such a way that it significantly reduces the harmful emissions as compared to direct combustion process. The sulfur is removed more than 99% in elemental sulfur form so that fertilizers and sulfuric acid can be made. Similarly, NOx and CO2 is also way lower in gasification process. Overall, the main driver for rapid investment in coal gasification is to become self-reliant in gaseous fuels as well as fertilizers, so that to mitigate global supply chain shocks. Here we can see various recent developments in coal gasification in India. Jindal Steel plant is already using it to make steel. CIL has also recently formed JVs with BHEL, GAIL, as well as fertilizer manufacturers like RCF and FCIL to produce urea, ammonium nitrate, as well as SNG. Here we can see two of BHEL's small-scale coal gasification plant as a technology demonstrator. The versatile nature of gasification also gives a strategic advantage to produce even more products like hydrogen, liquid fuels, as well as electricity through IGCC process in the future if it demands so. Thank you.
Thank you very much, team MTPS. Any questions, judges?
Sir, this is as per Ministry of Coal report during the auctioning of coal mines. This is derived from Ministry of Coal website.
Thank you very much. Now I would request our esteemed judges to kindly felicitate team MTPS. This is a small token of appreciation from DVC to the talented team of MTPS. Audience, huge round of applause is expected. And now it's time to felicitate our session judges, and for that I would request Sri Vivek Rastogi sir, Senior GM, Corporate Operations Services, to please come up on the stage. The whole session was very meticulously managed by the esteemed judges. The session was full of knowledge and was a long session. Ladies and gentlemen, with this, we come to the end of first session for the day. And we will now break for the lunch. And we encourage you all to use this opportunity to network and continue informal discussions with your fellow experts and delegates. And we will reassemble here in the same hall after the lunch. And please try to be on the time so that the time schedule is maintained. Thank you very much.
শান্ত হলো ক্ষান্ত হলো মত্ত চরণপাত, অভয় বরে সুপ্রসন্ন উদ্যত আঘাত. This simple yet stunning couplet written in the impression book of Mazumdar Nivas by novelist Tara Shankar Bandopadhyay, enlivens an entire canvas. DVC was established soon after independence as an entity to control and manage the Damodar River. It was a unique project at that point of time, with multifarious responsibilities. The notoriety of the river Damodar was such that the people living in proximity were mortally fearful of its destructive powers. It was the flood of 1943 that left great destruction at its wake. The impact was such that the inhabitants expressed their sorrows through songs.
दामोदरे बहानेलो भासलो घर खाना हाय हाय भासलो घर खाना हरि हे कृपामय पथ देखाओ ना हरि हे.
The devastating flood of 1943 was an important stimulus for the formation of DVC. In the same year, the government of Bengal appointed a 10-member inquiry committee titled Damodar Flood Inquiry Committee, under the chairmanship of Bahadur Uday Chand Mehtab, the Maharaja of Burdwan, and the noted physicist Dr. Meghnad Saha as members for suggesting remedial measures. Their magnificent work paved the way for Damodar Valley Corporation as a corporate body and the only solution to a river basin problem. On the lines of Tennessee Valley Authority, Damodar Valley Corporation came into being on 7 July 1948. In these 75 years of constant functioning, DVC has been successful in taming this wild river. The vision of DVC is to be an integrated, diversified and sustainable power major, ensuring socio-economic development of the people and creating value for the stakeholders. DVC's command area is spread over 24,235 square kilometers in Jharkhand and West Bengal. Our assets include 4 dams at Tilaiya, Konar, Maithan and Panchet. Tilaiya Dam on Barakar and Konar Dam on Konar had their inception in 1953 and 1955 respectively. The length of Tilaiya is 366 meters. On the other hand, the length of Maithan Dam on Barakar is 4,427 meters. And Panchet on Damodar is 6,777 meters. These had their inception in 1957 and 1959 respectively. These dams help the water resource management of the corporation. DVC has supplied water thrice every year from its surplus water for irrigation purposes. There are automated rain gauges in all the dams that provide a quantitative forecast of precipitation. Damodar Valley Corporation, over the last 75 years, has developed a robust transmission and huge distribution network and expanded it from 132 kV to 220 kV. And from 220 kV to 400 kV to serve its consumers and export power to other regions. Today, DVC is supplying power not only in its command area, that is Jharkhand and West Bengal, but throughout the country, and has a presence in Kerala and Karnataka in the south and Madhya Pradesh in the center. In the north, DVC supplies power to the states of Delhi, Haryana and Punjab. DVC became the backbone of the country's steel industry in eastern region, electrification of the railways and development of numerous big and small industries in its command area. DVC has a power plant simulation training center at Mejia Thermal Power Station that provides simulator training to its employees. Various training programs for the employees are conducted regularly. The Damodar Basin has a rich cultural heritage. for development, promotion and strengthening of education in its command area. DVC owns 18 schools where more than 16,000 students are presently enrolled. DVC relentlessly strives its best to cater to the dreams and aspirations of these children. In order to help the rural unemployed and underprivileged youth, DVC organizes various skill development programs.
যে এখানে এরকম ফ্রিতে সেলাই শেখানো হয়, এখানে 6 মাসের ট্রেনিং আমি করি। ম্যাম আমাদের খুব যত্ন সহকারে সেলাই শেখান, তারপর আমি অন্যের অর্ডার ধরি আমাদের গ্রামে, আমি বাড়িতেই বসে সেলাই করি।
DVC has always given prime importance to the health and welfare of not only its employees, but also the people living in the valley area, giving a plethora of services. The corporation also facilitates community health service through treatment of villagers at doorstep by 12 well-equipped mobile medical units. Each mobile medical unit moves with a doctor and a pharmacist and provides free treatment, including doctor's consultation and medicine distribution. Additionally, DVC runs 6 full-fledged hospitals with modern infrastructure, providing preventive and curative services to 2.8 lakh villagers. For combating soil erosion and soil decay, 17,193 check dams covering over 4,744 villages had been created since inception of the DVC.
यह ज़मीन पहले बंजर था, इसमें किसी तरह का फसल नहीं होता था, लेकिन डीवीसी का बहुत बड़ा कृपा रहा। यहाँ जब से चेक डैम बना है तब से हम सब किसान लोग खुशहाल हैं, नाना प्रकार का फसल पैदा करते हैं और उससे अपना परिवार का पालन पोषण करते हैं।
Damodar Valley Corporation constantly and consistently cares for our Mother Earth and thus strives to work towards environmental upgradation. Since its inception, DVC has been working towards the soil erosion problems. The Soil Conservation Department at Hazaribagh has helped retain soil fertility for the sustained production of food, fiber, and fuel for the inhabitants. DVC creates awareness for value-added utilization of fly ash in making cement, bricks, and other ash-based industries.
আমরা এখানে এএসি ব্লকস তৈরি করি, এটাকে আমরা গ্রিন কেকও বলি, আর এনভায়রনমেন্টের জন্য কিন্তু এটা খুবই ভালো। আমরা এই প্রোডাক্টটা তৈরি করি ডিভিসির কাছ থেকে যে ফ্লাই অ্যাশগুলো আমরা পাচ্ছি।
Damodar Valley Corporation remains steadfast as a multi-purpose and multifarious organization committed to the growth and development of the nation and socio-economic development of its command area. After 541 kilometers of its journey, River Damodar meets River Hooghly. Faster adaptation to change, innovation, continuous learning and commitment to excellence will be the key drivers for the next years of India's one and only 75 years old, unique, multi-purpose River Valley project. Damodar Valley Corporation, under the Ministry of Power, Government of India.
यार बोर हो रहे हैं, घूमने चलेगा? कहाँ? वो दामोदर की घाटी में। अरे वहाँ क्या मिलेगा? आओ दिखाते हैं।
पंचायत में कुंड मिलेगा, हारों का झुंड मिलेगा, पंचकोट के गढ़ दिखेंगे, कोटे और पर दिखेंगे, मंदिर मिलेगा, झील मिलेगी, छोटे हाथी की फील मिलेगी, और मिलेगा पंचत डैम दामोदर की घाटी में। दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में, दामोदर की घाटी में। जय चंडी में शक्ति मिलेगी, तेल कुपी में भक्ति मिलेगी, दशहरे की साड़ी भी है, डोकरा शिल्पकारी भी है, कल्याणेश्वरी दहील मैथन की खूबसूरत झील, टापू मिलेंगे, जंगल मिलेंगे, और मिलेगा मैथन डैम दामोदर की घाटी में। दामोदर की घाटी में, दामोदर की घाटी में, है दामोदर की घाटी में, दामोदर की घाटी में। रजरप्पा में नदी किनारे देखो शक्ति पीठ पुकारे, पार्श्वनाथ शांत करेगा, कोनार खुशियां भर देगा, हजारीबाग में झील दिखेगी, फिर केनेरी हिल दिखेगी, बड़े बड़े जंगल भी है, नरसिंह का टेम्पल भी है, बैट आइलैंड झुमरी तिलिया, और मिलेगा डीवीसी डैम दामोदर की घाटी में।
पूष की ठंडी शांत सुबह और लहरों की चंचल कौतूहल, भोर के जागे खग विहग संग, मंद पवन भी करती हलचल, खड़े वृक्ष हरे भरे बहुत सारे, देखो मैथन डैम किनारे, मनमोह विहंगम दृश्य झील का, उस पर बैठा घोर कुहासा, मानो बादल चूम रहा हो सुप्त जलाशय के ललाट को, लेकर मांझी नाव चला रे, देखो मैथन डैम किनारे। दोपहर में मीठी धूप की कंबल हौले हौले देह तपाती, फिर ढलते सूरज की किरणें लहरों पे करतब दिखलाती, और सुनहरी सांझ ढली तो आई निशाले चांद सितारे, देखो मैथन डैम किनारे।
শান্ত হলো ক্ষান্ত হলো মত্ত চরণপাত, অভয় বরে সুপ্রসন্ন উদ্যত আঘাত। This simple yet stunning couplet, written in the impression book of Mazumdar Nivas by novelist Tara Shankar Bandyopadhyay, enlivens an entire canvas. DVC was established soon after independence as an entity to control and manage the Damodar River. It was a unique project at that point of time, with multifarious responsibilities. The notoriety of the river Damodar was such that the people living in proximity were mortally fearful of its destructive powers. It was the flood of 1943 that left great destruction at its wake. The impact was such that the inhabitants expressed their sorrows through songs.
দামোদরে বাহানেলো ভাসলো ঘরখানা, হায় হায় ভাসলো ঘরখানা, হরি হে কৃপাময় পথ দেখাও না, হরি হে।
The devastating flood of 1943 was an important stimulus for the formation of DVC. In the same year, the government of Bengal appointed a 10-member inquiry committee titled Damodar Flood Inquiry Committee, under the chairmanship of Bahadur Uday Chand Mehta, the Maharaja of Burdwan, and the noted physicist Dr. Meghnad Saha as members for suggesting remedial measures. Their magnificent work paved the way for Damodar Valley Corporation as a corporate body and the only solution to a river basin problem. On the lines of Tennessee Valley Authority, Damodar Valley Corporation came into being on 7 July 1948. In these 75 years of constant functioning, DVC has been successful in taming this wild river. The vision of DVC is to be an integrated, diversified and sustainable power major, ensuring socio-economic development of the people and creating value for the stakeholders. DVC's command area is spread over 24,235 square kilometers in Jharkhand and West Bengal. Our assets include 4 dams at Tilaiya, Konar, Maithan and Panchet. Tilaiya Dam on Barakar and Konar Dam on Konar had their inception in 1953 and 1955 respectively. The length of Tilaiya is 366 meters. On the other hand, the length of Maithan Dam on Barakar is 4,427 meters. And Panchet on Damodar is 6,777 meters. These had their inception in 1957 and 1959 respectively. These dams help the water resource management of the corporation. DVC has supplied water thrice every year from its surplus water for irrigation purposes. There are automated rain gauges in all the dams that provide a quantitative forecast of precipitation. Damodar Valley Corporation, over the last 75 years, has developed a robust transmission and huge distribution network and expanded it from 132 kV to 220 kV and from 220 kV to 400 kV to serve its consumers and export power to other regions. Today, DVC is supplying power not only in its command area, that is Jharkhand and West Bengal, but throughout the country, and has a presence in Kerala and Karnataka in the south and Madhya Pradesh in the center. In the north, DVC supplies power to the states of Delhi, Haryana and Punjab. DVC became the backbone of the country's steel industry in eastern region, electrification of the railways and development of numerous big and small industries in its command area. DVC has a power plant simulation training center at Mejia Thermal Power Station that provides simulator training to its employees. Various training programs for the employees are conducted regularly. The Damodar Basin has a rich cultural heritage. For development, promotion and strengthening of education in its command area, DVC owns 18 schools where more than 16,000 students are presently enrolled. DVC relentlessly strives its best to cater to the dreams and aspirations of these children. In order to help the rural unemployed and underprivileged youth, DVC organizes various skill development programs.
যে এখানে এরকম ফ্রিতে সেলাই শেখানো হয়, এখানে 6 মাসের ট্রেনিং আমি করি। ম্যাম আমাদের খুব যত্ন সহকারে সেলাই শেখান, তারপর আমি অন্যের অর্ডার ধরি আমাদের গ্রামে, আমি বাড়িতেই বসে সেলাই করি।
DVC has always given prime importance to the health and welfare of not only its employees, but also the people living in the valley area, giving a plethora of services. The corporation also facilitates community health service through treatment of villagers at doorstep by 12 well-equipped mobile medical units. Each mobile medical unit moves with a doctor and a pharmacist and provides free treatment, including doctor's consultation and medicine distribution. Additionally, DVC runs 6 full-fledged hospitals with modern infrastructure, providing preventive and curative services to 2.8 lakh villagers. For combating soil erosion and soil decay, 17,193 check dams covering over 4,744 villages had been created since inception of the DVC.
यह ज़मीन पहले बंजर था, इसमें किसी तरह का फसल नहीं होता था, लेकिन डीवीसी का बहुत बड़ा कृपा रहा। यहाँ जब से चेक डैम बना है, तब से हम सब किसान लोग खुशहाल हैं, नाना प्रकार का फसल पैदा करते हैं और उससे अपना परिवार का पालन पोषण करते हैं।
Damodar Valley Corporation constantly and consistently cares for our Mother Earth and thus strives to work towards environmental upgradation. Since its inception, DVC has been working towards the soil erosion problems. The Soil Conservation Department at Hazaribagh has helped to retain soil fertility for the sustained production of food, fiber, and fuel for the inhabitants. DVC creates awareness for value-added utilization of fly ash